We are going to start the fourth symposium on philosophy and science. So this is something not very usual in research centers, in Spain at least, but it's already the fourth year that we are going to be organizing this symposia. So the first thing I want to say is thank you to the speakers, to the invited speakers, as well as the co-organizers, Antonio Dieguez and Arantxa. So we had this idea, I think it was 4 or 5 years ago, and I think it has been a good idea, and this year, for the first time, we got some attention also from the media, so we'll have Spanish TV coming to the CNIO, etc. I wanted to take this opportunity also to tell the invited speakers, the ones that have never been here, what is the CNIO. So the CNIO is the Spanish National Cancer Center. So we are devoted to cancer research. We are accredited as one of the excellent centers in Spain, and here you can see some rankings. So at the national level, we are in the first position in the health sector. So this is our impact at the national level, and in the worldwide, you can see that in the cancer rank, we are in the number 8. So we are a competitive center for cancer research. We are basically a fundamental research center. So this is not a hospital. We don't see patients. We do research, discovery on cancer research. And we have agreements with hospitals, mainly in the area of Madrid, to also run clinical trials with some of the oncologists that are moving from the hospital to the CNIO. I just wanted to mention that we have a lot of agreements with industry, so we do a lot of innovation, and you can see here the agreements for this year with international and national companies and institutions, and we have a fair amount of funding that is coming from these agreements. This is in the last 12 years, more than 30 million euros. We also foster innovation. We have an agreement with one of the business schools just next door, which is called Instituto de Empresa. It's one of the top business schools in the world, and we also like to foster this innovation culture. And finally, we do a lot of training. So you can see here the symposia that we are organizing. These are symposia on biomedicine, different subjects, the 2 that we had this year. We also have what we call distinguished seminars with key opinion leaders and key scientists in the field of cancer research. And this science and philosophy symposia, this one that we have today, is the 4th one. And I just wanted to tell you that we also have a lot of mobility programs. This is for sabbaticals. So these are different scientists that came to the CNIO to do stays with us. And we have one very important with African women. So these are African scientist women that come also to do sabbaticals to the CNIO, and it's a way to help them when they go back to their countries of origin. And we also have a lot of activity. We have a women's and diversity office, and we have this women and science. We have women from all sectors. Actually, we also had some philosophers, writers, etc., that come and tell us about, breaking stereotypes, and this is something very good. And I will be also finishing with something that is quite unusual. We also have an initiative that we call CNIO Friends, and we have donations from society to the CNIO, and this is the amount of donations that we have. It's not like in the UK, for instance, but this is quite new for a research center to do this and to get funding to. For instance, we have an international postdoctoral program thanks to these donations. Something very different that we do, and I also wanted to convey it to you, is that we organize something called CNIO Arte, and every year we foster that a scientist and an artist meet, and from different research of science, and as a result of this, there is a new work of art that is created, that is generated. And this is exposed at the CNIO. This is another couple of artists and scientists. This was on quantum physics. And this is presented at ARCO, is the main contemporary art fair in Madrid, but also, for instance, at the CCCB in Barcelona, which is a leading institution for thought, art, and society. And we present this in ARCO, and these are the different couples, scientists. Arzuaga is a paleontologist. He's leading the Atapuerca. The word is not coming. The Atapuerca is a place in Spain where many skulls have been found, and it's really one of the top places in the world for understanding the history of human Homo sapiens and previous species. And these are different artists and that we had. You can still see the last Cenio Arte that is exposed here by Susana Solano. Is one of the main, the most famous sculptures in Spain, more internationally renowned. And this year we will have Amparo Garrido that is going to create a work of art based on the work of Elizabeth Blackburn. And I will finish here. We also foster or receive works of art that can be exposed at the CNIO. This is a piece by Marina Vargas. And this year, for the first time, we will itinerate this collection through the world, through the Instituto Cervantes, which is the main Spanish institution to foster the Spanish culture around the world. And we will be opening in New York, Cenio Arte. And I will finish here. We also have artistic residences. And this, I wanted to tell you that the CNIO, even though we are a research institution, we're interested in conveying to society the importance of science, and also that this place is a place where we can think about art, but we can also think about philosophy, and that's why we are here today. So I will pass now the stage to Arantxa to introduce the meeting.
Thank you very much. Welcome, everybody. Good morning. Today's seminar should be understood as a celebration of science, which is very needed today in current society, and also a celebration of philosophy, which is also very needed. And this is the fourth event of science and philosophy, funded by the Banco Sabadell Foundations that we do here. Sadly, the second and the third had to be online, but we have managed to arrive to this one, which is presential, and it's very important for us. So, and especially it's very important, the topic that we have today, which is the long-term view. We have this very brief description of the topic, just as a starting. In our program, since the mid-1980s, we have entered an ecological and social crisis, which is now undeniable. We are torn between a very worrying present and the uncertainty of how what we do now will affect the future of the planet and humanity. Science itself may be changing now in the wake of artificial intelligence and big data, and long-termism is a philosophical view concerned with the task of developing an ethical thinking that takes into account the beings of the future. It's not going to be technically about long-termism, but it's going to be about anticipation of the future, what we have to do in the present to anticipate the best future that we can. And we, the organizers, Antonio Dieguez, Maria Blasco, and with the help of Mercedes and lots of people in the CNIO, we are very happy and very proud of the speakers that we have gathered today. And I think they will raise very important issues. So we will start now with the first session. You know that there are going to be three sessions around this topic. Just a little notice before we start that we have decided, because of our needs of arrangement, to cancel the first pause. So the first break is going to be cancelled, and we will continue from the first session to the second straight away. And after that, we will have a break that is going to be a little bit longer, 20 minutes instead of 10 minutes. I hope this is fine for everyone. So the first speaker today is Irene Gómez Franco, and she will talk about climate ethics and global justice for future generations. Irene Gómez Franco is actually at the Autonomous University of Barcelona and the Open University of Catalonia, and also a visiting researcher since 2010 to the Institute of Philosophy of the Spanish National Research Council, the CSIC. And she is the author of this book, Deudas Pendientes, La Justicia entre Generaciones, Pending Debts, Cross-Generation Justice. And without much more ado, I will give you the word.
Well, thank you very much for the invitation to Antonio, Arantxa, and Maria, and to Mercedes also for the organization. Well, today I'm going to talk about the idea of justice for future generations in the context of climate change. One of the most serious problems of today's democracies is that future generations do not have a voice. Yet we know, as scientists warn us, that human action has produced and will continue to produce changes and transformations on a planetary scale that will have an irreversible negative impact for thousands of years to come. This is unprecedented. The range of human action and its effects is no longer limited in space and time to the repairable sphere. Now our entire planet is threatened by human action itself. We continue to produce an almost exponential increase in anthropogenic carbon emissions. We are 80% dependent on energy generated by fossil fuels, and there is no binding commitment from countries regarding energy transition, as the latest climate summit, the COP27, has revealed. This is, without doubt, the most striking fact of our time. But in the face of this opportunity to take on humanity's greatest challenge, we are approaching the problem in a narrow and limited, from my perspective, manner. The ecological crisis is, for the most part, monopolized by scientific and economic discourses. My claim, however, is that it is a fundamentally an ethical problem. I do not deny that there are many facets to this challenge, and some problems, like the deforestation in Amazonia, for instance, are ecological and economical and political, but I'm convinced that these issues demand not only the attention then of politicians and scientists, but the debate must also be brought into the field of ethics in order to combat parochialism and self-serving interest. Ethics help us to put the questions in the right place. For example, what is fundamental for us to live flourishing lives? Do we want to leave to future generations more green spaces or less? Do we want to coexist with other forms of life or not? We are really asking about what we want to preserve and why. We also have to ask ourselves, how do we take responsibility for the fragility that we have created? As Stephen Gardiner states, what matters most is what we do to protect those vulnerable to our actions and enable to hold us accountable, especially the global poor, future generations, and non-human nature. I think this cartoon reflects very well the problem that I'm going to approach today. I believe that people's lives have equal moral relevance regardless of their distance from us in either space or time. So, Is it then unfair that people in the future pay the price for our actions? Power is distributed unevenly among living generations. This is clear. The effects of climate change are already hitting poor and vulnerable people, and this is not likely to change. Intergenerational power relations are even more asymmetrical. We have the capacity to affect future generations, but they can never directly influence and affect our lives. So, what do we owe the future generations? The idea of intergenerational justice is constructed along 3 axes: theories, metric, rationale, and scope. What we call currency in our terminology, our philosophical terminology, or metrics, that's the what. Then we have the temporal arc of obligations, the scope, and the reasons we have for caring about the future. So why should we care about future generations? The rationale. Here we have this very simplified overview of this axis, as well as some of the theories, some distributive theories, others more like put more accent or attention on the communitary bonds or links, and then we have other perspectives that are growing interest and attention from the Global South and the colonial thinking, also very important, like Ubuntu or Buen Vivir. I'm just going to, because we have this limited time, so I'm just going to focus especially on future generations because of this long-term view, so not next 2 generations, children and grandchildren, but also remote and future generations. And I will use concepts and terminology from the capabilities approach. Freedom 2, this could be Amartya Sen. Flourishing will be something, Martha Nussbaum will use this concept as well as dignity, or real opportunities too, also in Amartya Sen's terminology or language. From the point of view of public policies, short-termism isn't always harmful. It is damaging, however, when it prioritizes the well-being, opportunities, capabilities, net benefits of the present at the expense of the future. This is a crucial idea because one of the most important methodological issues nowadays is how we set priorities between the well-being of our contemporaries and future quality of life. Some progress is being made in this direction. Policies like tax increases, subsidies, investments in this transition to a green economy, for instance, they have a cost in the present geared towards a benefit in the future. What is the logic of these policies? The logic of these policies is that avoiding bearing cost in the present means that their consequences will be greater in the future. So in the case of climate change, if we do not act quickly, adaptation, so to adapt to the effects of climate change, and mitigation, so to mitigate the effects in the future, will be increasingly costly. The cost of climate change falls most heavily on future generations. Adopting a short-term view may be motivated by several factors, as I wrote here, so you can find here just a few. The lack of a clear link to the long-term consequences of certain policies may lead to demotivation, so the individual feels demotivated. Institutions may be too weak, corrupt, or susceptible to the pressures of economic and political interests. From individual spheres, from the microsphere, Some philosophers will talk about lack of empathy or selfishness, procrastination. So they could also may play a part. However, all is not lost. I believe we have the capacity to care for future generations and that the tools to repair our relationship with the lie in the long-term thinking. I define long-termism as an ethical and political attitude in the present, so departing from the present action, that takes responsibility for the well-being of the people of the future. The ecological fragility we have created does mean it's not the fragility linked to living and dying of the natural world, but it's a fragility we, with our action, have created, compels us to devise new categories, one of which is that of intergenerational responsibility. This concept is little explored and remains unresolved in ethics and political philosophy, but this new category, that I particularly like, is essential because our familiar concepts of what we are responsible for, even in juridical terms, legal and juridical, be responsible, have the guilt or be imputable, or even being capable of being responsible for, are not enough. As Ricoeur said, by increasing the radius of our actions, we create new spheres of fragility and responsibility. I'm not going too deep more in this concept. This is a philosophical concept, a political and philosophical concept. Do you have any questions? We can talk about it later. So how do we go about this intergenerational world building? I would like to propose 5 principles that I consider to be very fruitful points of departure for thinking about and enacting intergenerational justice and the ethics of long-termism. The first key issue that I want to highlight is the relationship between historical and global injustices and intergenerational justice. Merle states, intergenerational justice is a sphere of global justice. For intergenerational justice, to think in terms of intergenerational justice, we have to take into account historical and global injustices. We are interdependent and our resources are not fairly divided. It is difficult to see how to think about our duties to future generations without considering present global inequalities, as well as historical injustices. The factors that are endangering and impoverishing life in many parts of the world today are closely related to patterns of inequality derived from colonialism. So the reality is that only rich countries can afford the cost of adaptation or mitigation in the face of climate change. Here we have a quote of the Intergovernmental Panel on Climate Change. I think it shows very well what I want to communicate. Regions and people with considerable development constraints have high vulnerability to climate hazards. Vulnerability at different spatial levels is exacerbated by inequality and marginalization linked to gender, ethnicity, low income, or combinations thereof, especially for many indigenous peoples and local communities. Future human vulnerability will continue to concentrate where the capacities of local, municipal, national governments, communities, and the private sector are least able to provide infrastructures and basic services. A second point worth noting is that long-termism is not only about sustainability. As the Brundtland report, this very famous Brundtland report that approximates the concept or poses the concept of sustainable development. Sustainable development says is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. We, as philosophers, like to distinguish between means and ends. And I believe that too much emphasis has been placed on the means of sustainability, rather than thinking about its objectives. It is crucial, for example, to consider the different ways in which resources and goods are transformed into freedoms to live a life worth living. So people don't transform resources and goods in the same way and in the same level into freedoms to live a flourishing life because of numerous factors. Also including, from an intergenerational perspective, the times in which they live. If we rush headlong into strategies of sustainability that don't consider the ends to be fundamental, we run the risk of not actually meeting the needs of the future generations, for whom we are supposedly engaging with this daunting task. The risk of perpetuating the status quo rather than achieving truly transformational outcomes. For us to be real actors of substantial change, it is necessary to include all interest groups, not just expert and economic players, in public debates at the international level. The crucial political question is the distribution of power among as many individuals as possible. This global public sphere of discussion is necessary, now more than ever, and connects with the idea of democracy that Hannah Arendt had in mind. Democracy understood as a reconstitution of the forum. We have a responsibility to promote education as a key factor in creating our common world. And imagination, this very special faculty we have, in its political sense, think possible futures, and moral sense, to put oneself in the shoes of others is fundamental in this respect. There are also, as Martha Nussbaum says, humanities, arts, critical thinking, they contribute to educate this imagination. And finally, the design of institutions and their structural framework is key in correcting intergenerational injustices. On a mostly positive note, there are already instruments to add this intergenerational perspective to existing institutions, as well as institutions created expressly for this purpose. I say mostly positive because some of these have better chances of success than others. Finland, Hungary, Israel, New Zealand, Wales, Canada, to give a few examples, have or have had an office in charge of protecting the needs of future generations. These offices have highly specific goals, but sometimes struggle to be effective as they depend on a complex network of institutions for the ability to enact change. United Nations, this is something I really would like to highlight. In the Secretary General's 2013 report on intergenerational solidarity and the needs of future generations, also proposed a special High Commissioner for Future Generations. But it is a real shame that this does not seem to have to come to fruition. So it was on the table, but never happened. Mechanisms within existing institutions may benefit from better infrastructural support, even if they do have to contend with mixed agendas and politics. Ecuador, for instance, Germany, Bolivia, Kenya, Norway, South Africa, have constitutional mechanisms for intergenerational thinking. You can see in this slide a list of just some of the main international agreements and declarations that have been signed. I mean, the list is very, very long. I just picked some of them. I believe that both strategies of implementation are valuable and also complementary. Now I'm concluding. To conclude, we're faced with this truth. Climate change is here. The critical issues are how to respond to it, where we focus our efforts, and what is valuable in the real lives of people. What do we want to preserve and for whom? In other words, how do we rebuild our common world? But this common world is not just about humans. What about non-human future lives? A pending task is how to conceive of interspecies, intergenerational justice. There was a butterfly there, but now it's just a square. A livable world depends on a vibrant earth with other life forms flourishing rather than being mere instruments of our own ends. I close with a final optimistic note. In late 2019, protests calling for strength climate action reached an unprecedented level of over 6,000 events in 185 countries, with a reported estimate of 7.6 billion participants. In other words, there is a growing awareness and concern among the people, particularly the younger generations, that what we must do is take full responsibility to ensure that all living beings, present and future, have the opportunities, capabilities they need to live a flourishing life. Thank you very much for your attention.
Thank you, Irene. Unfortunately, we don't have time for an extended discussion now, but if someone has one urgent question, we could take that. Otherwise, you can take your notes and keep your questions, comments for the debate at the end, which is going to need being nourished by your thoughts and your commentaries, please. Okay? So, questions? Well, I will present the next speaker then, Dr. David Nogués Bravo. He's full professor at the Center of Macroecology, Evolution and Climate in the Faculty of Health and Medical Sciences at the University of Copenhagen. And you have his bio here, but I will read something more. His research mission is to provide research-grounded, I like this, evidences for policies anticipating and mitigating the loss of biodiversity under global change. And he also researches on the links between biodiversity and human health. You can also see that he is a very, very accomplished researcher with lots of citations. And his title today is Global Biodiversity Decline in the Anthropocene. So,
thank you. I don't know if the micro is working. Can you hear me now? That's perfect. Thank you a lot. I will not be standing here. I'm really useless when it comes to stand giving a talk. So thanks to CENIO, thanks to Banco Sabadell also and the foundation to organize this. It's a pleasure to be here today. I'm really excited to be sharing time with colleagues that are far away from my research area, but with common interest. So I'm David, as you have seen here. For many years, I was part of the Faculty of Science, but the University of Copenhagen has decided to move 100 natural scientists from Faculty of Science to Faculty of Medicine, given the links that are these days between global change, human health, food security, and other aspects. So that's why I'm here. I'm a new member of the faculty, and part of my new research is trying to link global change, nature, and health. So, I would like to bring you today in a travel through time. Basically, much of my research over the years have been trying to predict the future. But for doing this, the only way we have for doing this is to travel across time and trying to understand how nature works. So for that, we usually come back hundreds of years or thousands of years. And we try to understand what happens with climate change, what happens to animals and plants. And we try to fit this knowledge into our models to try basically to predict what might happen to nature in the next 50 years, 100 years. So much part of my research, it brings different disciplines together, from biogeography to population genomics. As you can see, some of my totem animals that I work with is the woolly mammoth. So by trying to understand why the woolly mammoth went extinct, I can try to infer what are the mechanisms that brings a species to go extinct. And so come with me in this travel from the past to the future to try to understand what nature might look like at the end of this century. So maybe the first thing I would like to bring the main message, we are really living in a crisis of biodiversity. And this is something that might sound like an alarm, but when we look at previous crises on biodiversity, we are really walking the way. And it's really cool to see how, humans, 50,000 years ago, we were other kind of megafauna species. Homo sapiens sapiens were around the landscapes, and they start to make the first impacts. Then, of course, we become more clever and wiser. We have the Neolithic revolution. And it's in that moment we start to influence our ecosystems. And then, of course, we have the Industrial Revolution. And here is when our ability to control the energy fluxes of this planet increase in exponential manner. So the high story of the biodiversity crisis today is also the high story of our own species. We are fully interlinked into that. So just let me bring a bit the concept that you are going to be listening here most of the time, and this is biodiversity. I don't work usually on a specific species or system. I'm looking at the emerging properties of ecosystems, and one of them is the biological diversity. And I also think that biological diversity is not only the diversity of the species, it includes the diversity of genes and the diversity of ecosystems. So it's a hierarchical concept. And all these three levels, genes, species, and ecosystems, are fully linked. So that's my object of study. So here you can see a small David, when he was 5 years old, with his dad going to the mountains. We were at 340 CO2 ppm. These are pictures of me in different moments of my life. As you can see, you and me, we have been living in a massive moment of change. Usually we don't stop to let that sink. But that kind of change of these CO2 levels in only, I'm not that old, in not that many years, it's something that we have not seen many times in the history of our planet. So the change is on, and this change, the footprints of this change, are all over around the world. So let me bring the first strong message. We are transforming the planet as maybe we have never seen, not at least in the history of our own species, and most likely in some hundreds of thousands of years. So let me bring you first here, right? All of you know more or less about this. We have been warming up the planet at least 2 degrees only in the last 100, 120 years. As you know, the Paris Agreement was trying to stop this warming at 2, 1.5. We are moving beyond that. There is no way we're going to be in the next 30 years where the Paris Agreement is trying to look. Think on climate as a train. When a train is at 80, 100 kilometers per hour, it doesn't stop in 1 second when you push the brake. There is an inertia. So even if we will stop now all the emissions and all the drivers behind climate change, it will keep happening for some time. The future looks even more grim. We are going to see increases in temperature that are maybe more close to the 3 and 4 degrees than to the 2 degrees we would like to achieve. That is clear. But it's not only climate change. Let's gonna travel to the beginning of the 18th century. You have here the big European empires, the Dutch, the British, the French, the Spaniards, moving around the world, starting to really bring the technology they have. But not only them, of course, in other areas of the world in which the civilizations has been long standing, we had, of course, agricultural lands, but much of the world was still a kind of what we call a natural world. You move 3 centuries, and as you can see here in those colors, these brown colors, basically those are areas that has been transformed from natural areas to croplands and pastures, basically to feed our own species. So as you can see, we have only in the last 300 years, massive change in our planet. So we have been basically changing how, not what the planet looks like, but how the planet works. Sometimes it's not easy to visualize those changes, and I love this slide. Let that sink also, how the world will look like in 30 years from now. This was a paper published a few years ago. Climate in Madrid in 2050 will be similar to the climate today in Marrakesh. London's climate, maybe for the happiness of our British colleagues, will have the weather of Barcelona today. So this is the magnitude of changes we are expecting when we look at our models to predict future climate change. It's just mesmerizing, I might say, right? And think also how that will impact Spain, for example, Madrid. Lack of water, maybe other new kind of respiratory diseases can come with this. So the future, we need to start to think about and to get ready for it. Huh? So what is going on? We have seen now, okay, humans, we are transforming climate, we are transforming land uses. How that affects to biodiversity. This is a report that came just last year. This is a summary of hundreds of thousands of papers in the literature. As you can see, like over the last 50 years, in almost every single continent, populations of vertebrates are on decline. We are losing populations. It's not only we are losing some species, we are losing thousands and thousands of populations. South America maybe might be the continent that is suffering more. So we are living in a world in which we are pushing climate beyond boundaries that maybe even we can understand. We have transformed the planet globally. As a consequence, we have biological diversity going into decline. So let's kind of think, okay, but how big is this decline? So this paper by some colleagues from Germany some years ago, this is extinction per million years, right? If this is really high, there are many extinctions. If this is really low, there are few extinctions. So how do we can compare the actual extinction crisis? That's because we have many fossils also, and we know how many species went extinct in the past, right? We also have recorded by ecologists extinctions in the 20th century, and then we have models that predict the future. So what we know is like, if we compare the number of extinctions in the last century, we are moving into 1,000 till 10,000 times more than the natural background of extinctions. This is walking the way to one of the 5 or 6 mass extinctions in the planet. We are not there yet. I'm not going to be an alarmist here. We are not there yet. This is not like the Ordovician extinction yet. But we are walking the way. And we are walking the way so fast that might be difficult to decide, can we stop now or we are just a bit late? So my research, one of the aspects has been more focused is on genetic diversity. Is this level, that is not the species level, is the genetic diversity level. Sometimes we focus a lot on, oh, this species went extinct, this other species went extinct. Well, there is something that I like to call the silent extinction. We are not losing some of those species, but we are losing many of the populations and the genetic diversity they host. When we lost this genetic diversity, these animals and plants, they have more problems to adapt to future changes. So this is something that maybe sometimes is not in the media, it's not in the mainstream thinking, but it's one of the worst things that are happening. We are losing this genetic diversity in animals and plants. So over the last few years, my research team and with other colleagues, we have been trying to understand what is going on, how much we are losing, where we are losing. So one thing we found in the first paper, 2016, was this global analysis, was what we expected. The losses of genetic diversity across thousands of mammals and other vertebrates are in those parts of the world in which we humans will have transformed the landscapes in a more intensive way. Yeah? But we are still changing, right? So we are also trying to come with models about, okay, which parts of the world will be more highly impacted in terms of genetic diversity in 2070, for example, right? And of course, makes sense. You have the tropics. Let me try to explain those maps. Genetic diversity increase from left to right in this axis. Temperature change increase from the bottom to top. So if you are black color, it means you host a lot of genetic diversity. It's a highly diverse area, but will change a lot in terms of climate. Yeah? You see here, mainly the tropical areas are the ones that are these arcs of biodiversity, and that might be more highly exposed at the same time. And in the most recent paper, with some colleagues in Stanford, this came a few months ago, what we also found that globally, we have already lost the 10% of genetic diversity. And this is relevant because the United Nations last year set as a threshold not to lose more than 10%. But was not globally studied to know how much we lost. So we are already going beyond what thresholds United Nations has set up. So how do we know those things also, right? And how we try to anticipate the future, as I told you, is by traveling back on time. And one of the things that have been worrying us is not only change, it's the concept of abrupt change. So I work in Denmark, and of course we have big programs on Greenland research. And this is one of my colleagues, Dorte Dals. He's the head of the ice coring initiative in Denmark. So in this ice cores, using this ice core and the chemical composition of this ice core, we also can understand how climate has been changing in the past and how fast has been changing. So we use this to understand, okay, what might happen to nature if climate change at the speed that we know has been in the past, right? This specific core is a really old core. This is not used in this paper, but I put it because it's really cool. This core is the bottom of 2.6 kilometers core that went into the rock of Greenland. And what you see here are the sediments of the back of the bottom rocks. We also can extract ancient DNA, and we can reconstruct how Greenland was looking only 1 million years ago, right? So we use these kind of techniques, for example, to understand how climate has been changing over time. And what we are finding is when we look at the past, on the last 50,000 years, We find the climatic system, crossing tipping points, changing new conditions that sometimes we cannot even predict. Biotic systems, we see like species move around, many populations collapse, and some species go extinct. What are the consequences of that? We also have some understandings over the last 10,000 years that some civilizations in the past, they collapse, in part also because of environmental change, the inability to be fast enough to adapt to a change. So this is the way we are trying to understand the future, at least in my research field, is first by looking into the past and finding out what has happened. So now we are going to move a bit into looking how the future looks like, right? And I like to use this slide. It's a kind of a joke that came during COVID, but I think that summarized really well a really forgotten aspects. We heard a lot about COVID, right? And that was a really worrying experience for everyone. Of course, behind COVID was a recession, and there is a recession around. We are really aware how climate change might really bring our planet to the brink of being sustainable. But what many people don't understand is that the real crisis behind all those things is biodiversity. So in the next minutes, I'm going to try to explain you how biodiversity relates to societies, economy, and human health. But in a really simple way, sometimes we try to forget that we are other animal in the system. Homo sapiens sapiens, 250,000 years old species, one of the newest and most recent species of mammals in the planet. I think maybe the polar bear is around 400,000 years, and we are only 200. So we are the new kid on the block, and really, really fast as a species, we forget that we don't live in a bubble, right? So let me show you some of those links and how the future of the planet will look like for some of those aspects. Okay, so IPBES 2019, for you, maybe you don't know, in the same matter, in the same way that we have a IPCC panel for climate change, we have the International Panel for Biodiversity and Ecosystem Services. So this is in the same way that the IPCC, almost every single country is part of that. Hundreds of scientists reviews thousands of papers to have some kind of synthesis. So this was the last one that came 2 years ago. And this is not real trends, it's more a summary of what might happen depending on what we do. Yeah? So what we know by hundreds of papers and observations is nature is in decline. Yeah? Depending on what actions we take, we will go in one of these three directions. If we are able to protect nature, to have more sustainable production aspects, including food production, and also if we reduce the consumption, we might revert this trend and to come back to a more sustainable nature. If we only focus on conserving nature, but we don't think how we eat and what we eat and what we consume, we might have the chance to stop and to slow down this trend, but that's all. If we use or we follow the business as usual, which usually is the most likely, we are going to keep going down and down and down. And this is based on many, many projections with big computers, massive amount of big data. Now we have millions of records about how nature works. So we also use this artificial intelligence aspects to really try to predict the future, right? And this is really consistent. And it's consistent what we know from the past of our planet, right? Okay. So why this is relevant for us? You might ask, I mean, look, I don't care about the lions. Fair enough. It's not a bad answer. But nature provides services, right? What services nature provides? Well, soil formation. If you don't have soils, you have nothing to cultivate on top of soils, right? Flood control. When you have heard many times hurricanes hitting Florida, right? If you have the manglares, the effect of those will save lives and billions of US dollars. Because they don't have this nature to stop the power of the sea, they are losing billions and billions of dollars and lives. What other things nature brings? Clean water and air, right? If you have a forest, it might act as a filter to clean your water. If you don't have that forest, you might have other kind of water that maybe you need to treat and to spend a lot of money to treat that water, yeah? So there are so many medicines. Even 50% of the medicines these days are synthetic drugs. The other 50% are still coming from plants or inspired by plants, right? And this is one of my most current research lines. I will not have time to talk, but the amount of services that nature provides to us, it's not only allowing us societies to keep going, it also impacts a lot how poor or rich our economies will be in only 50 years from now. So, Deloitte, those are not the guys that are going to try to tell you, no, nature, nothing happens if we lose nature, right? Deloitte 2019, natural capital concept, and this is a concept becoming really used into economic forums, because we start to understand how much money nature makes for us, right? What is going to happen? Well, depends on the futures, right? Natural capital supports economic activity. If we move in 100 years into a world in which we are still having nature, our economy will be better. If we move into a world in which nature is downgraded, our economy might be much worse. Deloitte estimates that by 2050, and only based on 6 ecosystem services, and there are many more, based on 6 ecosystem services, the loss of not having those services might be close to the $10 trillion. And now let me put an example of those services. Many croplands, they need pollinators, right? With the pollinators, we are not. I have been in China walking around in some places, and because they don't have pollinators for these fruit trees, they pay hundreds of people to go around pollinate them, right? My colleagues in US, they were really good on getting funding from the US Army. Why? Because there are some pests that can go into a kind of cropland and be a key problem for US food security, right? So nature is around us. Sometimes we'll provide, of course, a lot of services for us. Other times might be a problem. But we need to think also in nature as an economic factor. This is not anymore 3 crazy ecologists that love butterflies going to the field to catch one. Yeah? I love this graph. This is made by the World Health Organization and the Convention on Biological Diversity. So in many ways, health is rooted in biodiversity aspects. Many of the health outcomes depends on how healthy is the biodiversity around you. Yeah? So climate change, food, water security, sustainable development, they have huge impacts on many different aspects. Biomedical discovery, for example. Might be plants out there that we don't even have described yet, and that we have never analyzed in a lab, that might maybe be really useful to cure diseases. We might lose these species even with know for what they might be useful for, right? So let me show you a couple of examples that relates to food security and to health outcomes as a matter of biodiversity and biodiversity change. Now we are going to travel into the year 2070. Given climate change, and this is maize production, this is what our models are telling us. Declines in the majority of the planet of a 20 to 30% on yield decline. The climatic conditions might not be there. Of course, the reality is more complex. Other areas will benefit, right? You can see here, this is the Andes. The Andes may be a bit cold now, but because they will become warmer, they will be at least not as warm as some parts on the lowlands. So there are massive amount of scientists working on food security these days. And one of the things we do is to try to model what will happen with the production of those species. At the end, maize is a species, like any other, right? Maybe an example that you might feel even more close here at CENIR, because it's more medical example. Now we're going to travel to 2070, and we are going to try to think about global viruses, right? And we are really close now. We have, of course, the COVID really recent. Because climate and land use are really intense, animals are moving around. Animals are contacting other animals that never contact before. So we are provoking these new interactions across animals. Some of these animals, they have viruses, and then we are growing. Humans are growing. Billions and billions of humans are growing. So some colleagues just recently published this super cool map. So 2070, you have here in the densities of human populations, from the bottom to the up in this color gradient. This is the projected viral setting in wildlife, how virus will change from animals to animals. When we have this kind of scenario in which many animals might be having new interactions and contact with each other, and many humans at the same time in those areas, the probability of some viruses at the end passing to humans are really high. So which parts of the world are more exposed to that? Parts on this color, right? Highest densities. Okay, this is going to be the place to be looking at, one of them, not the only one. But here we have billions and billions of people. In 2070 will be other billions and billions of people, new people living there. We are destroying some of the habitats of these animals. These animals move around, they find others that maybe they shouldn't find, and we have this change of transmission coming. So this is a way also in which nature is affecting the future of our societies and our own health. So I don't have time today, but because this moved to the Faculty of Health now, I'm working on these two aspects. I'm starting a new PhD student, indeed, after New Year. So we are modeling the risk of dengue and malaria coming back to Europe in the next century. So we are doing models that is telling us which parts of Europe will be more exposed to have these vector-borne diseases, these mosquitoes back. So to provide policy recommendations mainly for countries. And then another thing that is really exciting me, I'm doing maps, global maps of bioactive compounds in plants that are used in pharmaceutical industries. Because we don't know even where these medicinal ecosystem services are in the planet. So the first step to protect them is to try to map them. So I'm going to finish now, and this is really short slide. There are many solutions. I don't want us to sound really negative. There is a way to change things. And if I will need to put my money in 4 places, this one would be the ones, right? We need to really control emissions to the atmosphere. If we keep heating the planet, we are going into conditions that not only our own species have never experienced before, what has been maybe millions of years in our planet never experienced. We need to really think on more sustainable food production strategies. This is a key aspect also, right? I mean, it's not going to work if we keep consuming the food that we consume. We need to think in other ways. We need to scale up cleaner energy sources. Of course, what are these clean energies is a debate. Some people is going to think, I mean, maybe it's wind energy, and other people is going to tell you it's waves from the sea. Other people is going to say, maybe it's not clean, but nuclear energy, it can help the planet also, right? And then, and this is more a biodiversity part, it's to protect 30% at least of the land and oceans, so we don't lose all this diversity, right? So this is a really exciting moment as a scientist like me, in the sense that we're in a moment in which we have a lot of data, and we have a big challenge to try to resolve, right? And I like to finish with this slide. Usually I teach here, and I come for research here every year. This is 80 degrees north. It's called Svalbard. It's an island that is really, really in front of North Greenland. And there is a really small university there, and some other crazy people living around. Why we are there is because the Arctic is a sentinel of change. And things are changing so fast that by studying here, we can see what our future might be. At the end of the century, models predict that Svalbard will be almost 6 and 8 degrees warmer than today. This is going to look so different, right? And we don't even know how this is going to affect us. So that really makes my job every day really exciting, but at the same time, like, gets me worried sometimes. So I'm going to finish here. All of this research I have shown is the results of so many other people and many other funding bodies. And just put a small selection, mainly of the youngest people around me. I didn't put all the other seniors. I prefer to focus on these young guys and girls that I really hope, as scientists, they will come to bring more and more knowledge about those aspects and to try to help us to take better decisions into the future. So I think that's all that I have for today, and many thanks for listening.
David. Just if someone has a very urgent question or quick.
Sorry, I just left the stage without answering questions. I'm really happy to answer any questions.
Take your time. Well, yes, Maria.
You mentioned changing our food consumption. What do you mean exactly? Could you develop that?
Yeah, I mean, the way we produce food, right? I mean, we use a lot of fertilizers, for example. That has a really bad impact on nature. And then what we eat. Maybe there are resources that we might use more, like resources from the sea, like algae. Can we eat more algae? I know it's not for everyone. Can we reduce our consumption of cows and beef? So we know that the amount of energy that takes to feed a beef over 5 years is so massive that it's not a sustainable kind of meat anymore, and a big lover of meat. I'm not a vegetarian person, but that's something maybe we should really consider, right? The amount of meat we consume is not sustainable. And I don't think our own species needs so much meat. I mean, we have been, of course, our brain is the way it is because we had a lot of meat and proteins, but there are the kind of proteins also out there, right? Then you need maybe to adapt the kind of crops to the kind of environment. I mean, you go to many African countries and you see big banana plantations owned by the classic American companies. And maybe we eat bananas here, but the people living there, they don't have their own small croplands anymore, right? So they also will need some kind of sustainability system in which they are not expelled out from their own lands to have a monoculture that is only consumed in the rich countries. So these aspects of finding new foods reducing some kind of foods that we know they really have a huge impact in the ecosystems, and maybe also thinking on ways on how we can adapt some of our croplands to future global change, right? And of course there are things like engineered aspects for plants that maybe help us to those plants to be adapted to the future. So I think all those aspects are really important. But basically the consumption, the continuous consumption of food in a world that is increasing in population so high, it's something we need to consider really.
Thank you very much. So please, if you have other questions, take notes, and we can have those comments and questions in the debate.
Well, hello everybody. Our next speaker is, I think, one of the best thinkers in the world, thinking about the future of humanity, the existential risk, and possible solution to our most important problem. He is Anders Sandberg. Anders Sandberg is Senior Research Fellow at the Future of Humanity Institute at the University of Oxford. He researches at this institute centers on management of low probability, high impact risk, societal and ethical issues surrounding human enhancement. He is also very well known for his works about human enhancement, estimating the capabilities of future of technology and very long-range futures. He is a fellow for ethics and values at Raven College in Oxford, and he is a research associate at the Oxford Uehiro Center for Practical Ethics and the Oxford Center for Neuroethics, the Center for the Study of Bioethics in Belgrade, and the Institute of Future Studies in Stockholm. He is on the board of the non-profit ALFID and Artificial Intelligence Objectives Institute. So the floor is yours, Anders.
Thank you. Yeah. So I'm one of those academics who can't stay to one topic, and I'm very curious about questions like how large can the future be? How good can it be? What do we need to do to get there? But also, how much can we fail at it, and why? And what can we do about that? So, on March this year, there was a tiny asteroid that exploded north of Iceland. Probably no human saw this explosion, but it had the strength of a normal nuclear weapon. It happened in the high atmosphere. It was detected by some early warning systems. This was at the same time as the Russian invasion in Ukraine was getting bogged down. International tensions were really high. That asteroid could have exploded over Ukraine. The problem here is, of course, that could have been misinterpreted as a nuclear attack by one side or the other. And this is, of course, not the only time there have been real risk for a nuclear war by accident. In 1983, Stanislav Petrov literally saved the world by not pressing the button. He was in charge of the Soviet missile detection system. Suddenly, all the alarms went off. And at the time, the international tensions were really intense. And the idea of an American preemptive attack was very on the minds in Kremlin. People were seriously thinking that this was actually a likely thing. Petrov, fortunately for all of us, didn't quite trust the machines. His job was to check that everything was supposed to work as it should and then make the phone call, which would probably have led to a nuclear response. Fortunately, he didn't do as he was told and actually waited. He waited the longest 15 minutes of his life, and it turned out that, yes, it was an error. He literally saved the world. It wasn't good for his career, because he didn't do as he was told, but he saved us all. Indeed, during the Cold War, there were several other incidents like this that were very close to cause a nuclear exchange that would have at the very least ended much of our current civilization. Now, that was not the only time our species been in trouble. There is an argument that about 75,000 years ago, this wonderful placid lake in Indonesia, which is actually the site of a supervolcano, had a massive eruption causing climate change over the time scale of at least a decade, and that it decimated the human populations down to a tiny population. Indeed, there are some arguments that there was a genetic bottleneck that suggested that the number of human breeding pairs was down in the hundreds. This is debated. We're uncertain about it, but certainly supervolcanic eruptions have happened in the past and will happen in the future, and have threatened the survival of our own species. And of course, in the deeper past, other enormous flood basalt eruptions have caused mass extinctions, including some of the worst ones in the history of the planet. So these disasters belong to the category of global catastrophic risks and existential risks. So this is a diagram I stole from my boss, Nick Bostrom, where he argues that we can think of risks both in terms of the severity, how much harm do they do, but also the scope. Are they impacting just one person? Are they a local disaster? Are they a global issue? Do they leave traces that can be felt generations later? Or are they even permanent, affecting everything? So as people say, extinction is forever. If we go extinct as a species, that is going to affect all future generations. Even if something doesn't wipe us out, it might still cause scars that we might have to live with throughout the future. It might be that we lose potential and possibilities. Not all existential risks are about humanity going extinct. We could imagine a horrific totalitarian government that, empowered with artificial intelligence and good surveillance, can maintain its power indefinitely. To actually achieve that horrific vision George Orwell described in 1984, where one of the main villains explains that imagine the future of a boot stamping on a human face forever. That is a technological possibility we're approaching, and obviously something we need to avoid just as much as going extinct in a nuclear war or because of a supervolcano. A lot of the interesting questions here is, what can we do about this? Are there particular philosophical issues related to the badness of these risks? And what do we do about them? So I already mentioned nuclear war. Another problem we have is that our biotechnologies are getting much more powerful. And we already seen what a normal pandemic can do. And we were lucky. COVID, after all, was SARS-2. SARS-1 had a much higher fatality rate. If we had a COVID pandemic that instead had been as deadly as SARS, we would have a 10-fold higher mortality rate. And one can envision much more scary things. Indeed, right now in Geneva, the Bioweapons Convention is having a meeting trying to figure out right now how to strengthen our defense against bioweapons, because we're getting better at biotechnology, which is useful for saving us from diseases and illness, but also unfortunately allows us to construct worse things. Another interesting topic is artificial intelligence, which again is a tremendously promising technology that could actually help us solve many of our problems. But if malicious actors use it, it can amplify the power. And we also have a serious problem of controlling what artificial autonomous systems do. And they are getting more capable, much more rapidly than we are getting capable at controlling them. And we're also living in this complex, interdependent global system. It's not just in the biosphere that we're dependent on. We're depending on a technosphere where there are many problems, an economy that has a complicated set of supply chains, and they're all interwoven in ways that generate systemic risk. Climate change is going to push against this fragile, interconnected system, and that might cause global failures. I could, of course, keep on going through a long, long list of interesting and horrifying and fascinating kinds of disasters, but I'm going to skip on, because this is a talk that is both aiming at being more pessimistic and more optimistic than you would ever have imagined. From a philosophical standpoint, it's an interesting question. What is it that makes these really big risks bad? And there is a loss of value. Even if you discount all future generations, there's still 8 billion of us on the planet. That is a lot of people that can be harmed. There is also a lot of value in the continuity of our species and the things future generations might create. And it might indeed be that there is also a value in continuing the species. Some people say that it's mostly ethical consequentialists that care about existential risk, but I think that is a mistake. You can make an argument that's totally non-consequentialist, saying that we care about future generations and the ongoing project of humanity, and we have moral duties to continue that, just as our ancestors were trying to give us a better world. You can imagine the human project as building a cathedral where we're not nowhere close to finishing it, but we know that, and we're fine with doing this ongoing project, and it would be a shame to lose our track, to stop building it, or even worse, having it ruined. There is also this interesting thing about fairness. Often when we talk about disasters, justice is a very important factor, because it's the poor and vulnerable ones that are hurt the most in any form of disaster. Indeed, that is almost the definition of being poor and vulnerable. As the disasters get bigger and bigger, besides the actual harm, we also have a wider and wider justice question. Up until the point when we start talking about human extinction, at that point it seems like justice suddenly evaporates, because you need to have people around to have justice. If the world is empty, nobody has been harmed. There is nobody around to be harmed by the injustice. But I think that is a mistake, because there is also an intergenerational justice issue here. Instead, the justice is about all the future generations that were now prevented from coming into being. All their possibilities wasted if somebody presses the big red button or does a foolish decision on powerful artificial intelligence. Also, we want to have options. Being extinct or being under a tyranny, that loses a lot of options. Now, the good news here is actually that the natural risks are relatively small, it seems, compared to the ones we have created for ourselves. That might not sound like good news, quite the opposite of good news indeed, but it means that many of the risks that we need to care about are involved with the human system, which means that we humans actually have a chance of reducing and affecting them, which is by no means easy. It might be easier to deflect asteroids than to get nuclear disarmament. Partially because asteroids are a clean problem. They are moving according to the mechanics of Newton. We know roughly what happens if you hit them with an object, thanks to the NASA DART mission a few months ago. And you can build projects. It's nice and neat. Nuclear disarmament is a complex interdisciplinary problem that involves both politics, game theory, and many other things. It seems like our anthropogenic risks do dominate over the natural risks. But the good news is that we have this influence. Technological risks are particularly interesting to me because I'm trying to estimate where the limits lie of what technology can achieve. Now, the interesting part here is that many of the riskiest technologies don't exist yet. Right now, artificial intelligence is mostly a danger in terms of industrial robots squashing you, or very bad adverts being shown in your browser. It's not going out killing anybody yet. It's not warping the world yet. We have a chance of doing design ahead here to get AI safety built into the system. We can come up with ways of improving biosafety and rapid responses to new emerging diseases. We can probably figure out solutions to many of the interconnected problems. The systemic risk might be the biggest challenge because we don't yet have intellectual tools to handle them. So that might be worth working hard on. And indeed, there are many ways we can try to improve the resiliency against this. I don't have the time to get into that. Hopefully we can discuss that later on. But I think there are many interesting intersections here between improving ecosystem services, improving our food system, improving our survivability for big disasters, and so on. In many cases, it's not so much that the means we need to fix them are specific to a particular risk, but it's actually that it's useful for handling many problems. But I mentioned that I was interested in how big the future is. So now I'm going to turn to the very positive side. One interesting question is, can we speak about the vastness of the future, the grandness, in a useful way? And what do we even mean by useful here? One important issue is, are we early or late in the history of our species? It could be that we're very late. We don't have many years left. We should do the best we can with that in a few years. Or it could be that we're very, very early, which means, that, again, that we might not know enough. We might be very primitive. Future generations are going to be wiser, wealthier, more powerful than us. But we have this causal influence. The future generations might be a super civilization in the far future. But by pressing a button, we can wipe them out. By foolishly doing things, we might lose information or biodiversity they would dearly have wanted to have. Understanding our place in space and time is quite useful. And this is something I've been working on. So I've been working on this gigantic book project for some years, trying to outline what I call grand futures. Basically, where are the limits for what we could do if we survive and get our act together? Because quite often when interviewed, journalists ask me about existential risk, and then they wonder, but how do you even sleep at night dealing with these things? And the answer is, I'm a total optimist. I believe that the future could be fantastically good if we manage to get there, manage to survive, manage to actually reach the good part. And I do have an optimism about our ability to do that. We have overcome some pretty impressive challenges in the past, and I think we will. The interesting thing here is that normally when we think about the future, we tend to be rather close by. We think about when we will retire as the far future. And the future is a few years down the line. Probably we're still going to be living in the same apartment as we currently do when we reach the future. But as we start looking into nature, we see a deep past. Indeed, this was a revolution when it happened in the early modern era, in the scientific revolution. The realization that there was millions and billions of years of history where humans were not playing a role. There other forces were at play. Eventually, astronomers even found the ultimate limit of the deep past, the Big Bang. But from that also came this realization that, whoa, we're one species among others and might go extinct, but we might also evolve into other things. And the future, there is a deep future that might go very far. And you can even use some of our sciences to predict things about it. Again, I'm not going to try to get into the question of how to properly think about the future. There is a very interesting philosophical question about what parts of the future we can predict, what parts we cannot predict, what we can know we cannot predict, and what we can predict, and what we can say in the intermediate area. I'm just going to give a brief sketch of one method I've been using for this gigantic book project, and that's called exploratory engineering. So there are many technologies that we have, the little blue area. We know they work because we have them, or used them in the past, and could use them if we want. There are also some things we know are forbidden by the laws of physics. I can't make a computer bigger than a certain size because it's going to implode into a black hole. So I know there is an ultimate limit on the size of my computer. It's also going to overheat much earlier than that. So the laws of physics are banning certain technologies. But in between, there is this unexplored white area of perhaps possible technologies. So we can analyze this by saying, if we already have it, then we can do it. And we can also say that if nature does it, it's also fairly likely that we can eventually do it. Sometimes it might take a long while. We today have solar panels that are more effective than photosynthesis. They just lack the ability to make themselves like normal plants do, which is a technology that I actually have colleagues that are interested in making, self-replicating machinery. Another powerful and somewhat scary technology. Another interesting thing that we know is that when we can do something, we can automate the tasks, including building the machinery. One of the interesting consequences of this is actually that scale doesn't seem to be a limit for the activities of a civilization. We might still feel very small compared to nature, but as the previous talk demonstrated, actually we are already interacting with nature almost as equals, or in many cases, poor nature is being dragged around by us. That would have been inconceivable just 2 or 3 centuries ago. We have grown in power exponentially, and we're likely to keep on doing that. Indeed, the Russian astronomer Kardashev, when he was thinking about civilizations and looking for them in the universe, he noted that there doesn't seem to be any limitation really on how big and powerful civilization can be, except for the existence of the raw material, the energy, and the knowledge and time to do it. So he was interested in looking for very powerful civilization that would be visible from a long distance. What I've been doing in my book is basically I've been running through various areas of the world and trying to see, can I use exploratory engineering to see where limits lie? And now I'm just going to assert a lot of stuff. Because each of these claims requires a lecture on their own, why I actually think they're justified. We can debate whether they're correct or not. But from a physics standpoint, it's very clear that, yeah, we could have an extremely high material standard indefinitely in a sustainable way on Earth. That is the good news. Getting there is by no means easy. I'm not claiming that this is something that is just naturally going to happen. We just need to lean back and let the good times roll. I think technological determinism is a fundamental mistake. It looks like there are many mental and physical states that we humans already have that we can make widespread. Not just making ourselves smarter, but happier and healthier and more long-lived. And it seems that we could probably survive on this planet without wrecking the environment for not just a few thousand years, but millions and up to the natural lifespan of the biosphere, which is about 1 billion years. However, it also looks like we realistically could extend that lifespan of the biosphere, which raises some interesting environmental ethics questions about our responsibility for the biosphere. Even if humans are not around in 1 billion years, maybe we should still set things up to get a solar shield to safeguard the biosphere as the sun gets brighter, for the sake of the biosphere itself. Also, it turns out that expanding into space is another staple of futurism, of course. And again, I don't have the time to get into the argument, but it looks like settling the solar system is feasible. You can imagine something like the International Space Station, but equipped with self-sufficiency when it comes to food. Not necessarily even great hydroponic food, but it could be microbes and algae that you use. If you do asteroid mining, if you have automated manufacturing, really good recycling, then something like the International Space Station could probably over time settle the entire solar system, converting the asteroid belt into space for trillions of people. That's probably not the wonderful, beautiful vision we were promised in that old illustration from NASA in the 1970s, those pristine space habitats. But the first space habitats are going to be so expensive that the central Hong Kong is going to look cheap in comparison. You need to do a lot of space habitats before it gets cheap enough that you make nature preserves over there. We might want to strive to get there. But the interesting part here is that even the trivial thing means enormously long-lived future populations, because they're actually independent of the fate of Earth. They're just dependent on the sun not becoming a red giant, which gives you 5 billion years, and large amount of living space. Settling the stars seems to be much harder. Indeed, I have a doubt whether any organic human will ever leave the solar system. It might very well be that it's going to be artificial intelligence or digitized humans that eventually settle the galaxy. That is a sketch from a current project Starshot, that aims at using lasers within 1 or 2 decades to send off very small light sails to nearby stars. This is a serious project and they're making serious progress. I think they have a good chance of achieving something like that. That might be the way intelligence leaves the solar system. But were we to settle the galaxy this way, it turns out that the future populations is something on the order of 10 to the power of 29 people. That's 1,000 moles for the chemists in the room. That's a ridiculous amount of people. It seems like similar technology is taking up even more. I wrote a paper with Stuart Armstrong about this. Could settle a sizable fraction of the visible universe, giving totally unimaginably large populations and literally billions of galaxies. The interesting thing is, of course, that would imply survival for extremely long periods of times. If we were just like a normal mammalian species, we might survive on the order of 1 million years. But we might very well, being technologically advanced and widespread and ingenious, if we can survive mass extinction level threats, or at least some people can do that, then we could be around for 1 billion years. And settling the solar system would give us at least 5 billion years. If we settle the Milky Way, we're talking trillions of years until the stars go out. And if you start generating energy without stars, I'm very fond of using black hole accretion disks as a power plant. If I survive long enough, I'm going to have a future career as a black hole engineer. But that's for the far future. Then we're talking about that life and intelligence and technology could survive to somewhere beyond 10 to the power 33 years. There is an upper limit, perhaps, because of proton decay. It seems that matter itself is not entirely stable. We have never observed protons decaying, but most physicists believe that eventually it will become unstable, and that's going to be the end. But we've got plenty of time to work on fixing this. We might also notice that during this time there is energy and resource to perform a ridiculous amount of computations. Again, some of you are not computer nerds like me and might not care too much, but basically everything a civilization does, including actually evolution in the biosphere, can be regarded as a form of computation. It's the hook that links the world of value and complexity to the world of physics. And irreversible computational operations have a little thermodynamic cost, and you can calculate how much can be done thermodynamically. There are ways around that might vastly increase this. But the total amount of computations is really unimaginably vast. And as I mentioned, there might be ways of actually using matter, not just in the form of stars, to get this done. Indeed, it seems to be fairly doable. I have a worked example in one chapter in my book on how to literally move stars and then galaxies to move around masses on a ridiculously large scale. The only problem here is, of course, that you need to stay around and run this project and do some very, very impressive traffic management. Now, why would you care about this? Well, my colleague Guy Kahane wrote a really good philosophy paper on our cosmic insignificance, starting out with the stories about being under a starry sky and feeling very small and insignificant. And he notes that this sentiment, written about by many philosophers and poets, is very strange. Why should we feel insignificant when faced with a big universe? We can be insignificant in a tiny room too. Our significance has very little to do with the spatial scale of the universe. But there might be an interesting link here, and that is that life is potentially a transition of matter, a phase transition, literally a reorganization of matter. The biosphere takes atoms that normally would form fairly inert materials and create these tremendously complicated things that are replicating across the surface of the planet and changing, evolving. They have contingent properties. If you rerun evolution, you will get something different. Some of us on this planet are also contingent as individuals. If you've seen one C. elegans nematode, you've probably seen most of them. They're very similar. They have 303 neurons, and they basically have very few things they can learn. But any vertebrate becomes an individual as it grows up. We gain complexity. And that is a fantastic phase transition. It's, from a physics standpoint, really fascinating. Also, we know from cosmology that beyond scales of about 200 megaparsec, the universe looks more or less homogeneous. There are these galactic voids and strands, but beyond that, it looks like it's mostly a homogeneous mess. Now, if intelligent life actually goes out and starts moving galaxies and stars around for whatever reason, that would create a scale slightly smaller than that homogeneity scale. But it could also spread over larger scales. And this is where we get to the interesting thing in Kahane's argument. He pointed out that what measures significance is that if you describe something and leave out a detail, that detail is significant if the description is bad. If we talk about this room right now and leave out the fact that there are people in the room, we have kind of failed at describing what this room is currently like. If we leave out, let's say, some piece of furniture, it's probably not as bad. We are significant in this room. Now, I would argue that intelligent life, reorganizing matter on the vast scales, might actually make it significant for describing the universe, at least in the later eras. Leaving out intelligence and life is actually going to be a mistake. The largest structures are going to be because of intelligence. Now, the interesting thing here is, of course, the structure is dependent on what's being chosen. Evolution creates random new patterns. We humans have a fair bit of autonomy. We can decide, are we going to pave the universe with billboards or turn it into paper clips or happy computers, or maybe spread life and make a lot of biospheres, or just to prevent other species from messing it up? These are choices we can make. It's in some sense arbitrary. It's not set so much by the laws of physics as it's being set by what we want. So this is the interesting challenge. I'm going to rush past a few other things, but it's worth noticing that we have this interesting issue. These vast long-term projects, can they really be done? So while thinking about it, I went into macro history and tried to see, physics allows us to do vast things, but that might not be possible because civilizations and organizations fail. And another interesting thing that I found was, I didn't know what to believe among historians. They are too eloquent. They have beautiful explanations about why history must be cyclic or why certain things must or must not happen. There is a common idea that, yeah, civilizations rise and then they become stiff and decadent and then they collapse, which sounds good when you read it, but it might also be that that's just a good story. So I tried some statistics because I'm a nerd, and I basically took a lot of data and did survival curves and tried to see, is there a sign that you get an increasing mortality rate for empires, civilizations, kingdoms, or companies? And the answer turns out to be no. It's more or less constant. There is a little bit of infant mortality among startup companies and young kingdoms. They're not stable. But once you're up and running, actually the risk is constant. This is good news. Decadence might not get us. Unfortunately, it also seems to hint that it's more like bad luck. It's the combination of a climate shift and having a bad emperor and a bunch of barbarians showing up at the gates of the empire that will crash the empire. This hints that you need robustness against random chance, which is much harder to do than many other things. We might need to spread out. We might need to build a meta population where we have parts of our culture, our technology, our civilization, where if some part crashes, the other parts can resettle and repair the broken part. Again, I've been thinking a fair bit about post-humanities. If we're talking about humanity on these timescales, it's going to become something utterly different. Again, I will not have the time to get into this. There are interesting questions here about what do we actually want to turn into? There are many possible post-humanities that are absolutely horrific. There are others that are glorious. And most of them we can't even imagine. But it does look like we're increasingly not just using our technology to change our environment, but to change ourselves and what we are. And that, of course, gives us tremendous power, but also an even more powerful responsibility for ourselves, what we are. And that gets to these important questions about what do we want to do? What should we value? So you could argue that maybe happiness is the highest good. We should just be trying to maximize happiness across the universe. We should rush out and convert all pieces of matter into computers running happy states or maybe brains that are maximally happy. That is interesting because that happiness doesn't really need to send letters across the universe telling the other part of the universe how happy the minds in one corner are. They're just enjoying themselves. It creates a dynamics where you want to spread out very widely. But you could also say, actually, maybe it's more about computations that needs to be done. And right now it's too hot. It's 3 degrees above absolute zero in space, which is sweltering if you're a computer. If you wait a few trillion years, the universe is going to be cold and crisp. So maybe we should expand and wait and then do our computations. So then we should be sleeping for now. But you could also say, actually, talking, interacting, having a civilization, having a community, having an ecosystem matters. The causal connectedness is an important aspect of the world. And if we wait too long, the galaxies are expanding away from each other. In 300 billion years, they will all be gone. We are going to be isolated here in the local group with a merged Milky Way and Andromeda galaxy. Maybe we need to go out there and do that rearrangement of the stars, bring them together to the largest possible clusters, so we can then together have a long-running civilization. Another view is, of course, no, survival is what matters. We should be hiding somewhere safe and then just use energy wisely and stay around for a very, very long time. And then there are, of course, a lot of people, probably a lot of you in the room, that say, this leaves me cold. I don't want to move galaxies. I don't care about becoming weird post-humans. I want to have wine with my friends. I want to have a sensible social interactions in a sensible community that's sustainable and doesn't do anything too weird. And that might also be a totally correct view. I think there is space, of course, for modest futures inside the grand futures. Indeed, maybe most lives in a grand future are going to be modest. Some of them modest in very strange ways to us. But it seems like we have many options here, and I do think one can actually find ways of doing moral trades. If some of us computer nerds want to move to the far future because it's cold there, I guess the rest of you will say, yeah, bye-bye, sleep well, we're going to take care of the universe for the next few trillion years, and then you can wake up. We might make a deal with the people who want to have an Earth where half is set apart for rewilding and the other part for traditional societies. Just like the Amish people are living inside the decidedly non-humble United States and are in some sense kept safe by that, we might be able to set these deals. One of the interesting things this leads to is actually a lot of caution. This is a very optimistic vision I've been describing that says that we're super early and the total future value is literally astronomical. But the problem is, of course, that we're losing galaxies. If we're not rushing to the spacecraft today, we might be losing a galaxy per year that we could have settled and filled with value, whatever you think the highest values are. The problem is, of course, if we rush things, if we make a mess of things right now, that future is not going to happen. It's not just the future generations, but that entire grand future is going to be lost. So actually, the bigger the future seems to be, the more careful we should be about it. So this leads to this slightly funny conclusion that being very optimistic about the long-range future actually means that we should be more cautious in the near term. I've been having conversations with astronomers who want to try to signal to alien civilizations. And many other astronomers say, that's dangerous. That might be bringing doom to humanity. And the first group of astronomers say, yeah, but we're in so much trouble anyway. This is worthwhile. If we really think we're very close to doom, we must try very risky things. But if we think we have a lot of value, then we need to be careful. And one of the interesting things is that the grandness of the future seems to be doing less work here than the length of time. It's interesting to look where different resources and different values come from in this setting and how that can guide our actions. So, to try to sum up, what should we do now? Well, it looks like we have this tremendously grand future if we don't flub it. Okay, so we should be preserving options, we should be avoiding the risks. Also, it seems like that kind of expansion means that it's going to be hard to coordinate later on. It might be that right now we have this unique moment. We're all 1/7 of a second apart as the electron flies on Earth right now. All humans can communicate more or less with each other. We have a chance to actually get some joined up ideas about what we need to coordinate about, because eventually we will cease to be able to do that. It also seems that there are many of these technologies that I've been talking about are going to exist in smaller forms earlier on, and we might want to safeguard them and make use of them. Indeed, it's an interesting thing. When talking about the grand coordination, it might sound totally crazy because we all know what the United Nations is like. But 300 years ago, nobody could even imagine the United Nations, because how could the kings of the world get together in one place? There's no way of even traveling like that. Now we have this slightly dysfunctional organization that is still doing some coordination. We might imagine doing better forms of coordination in the future. Similarly, as we might want to come up with better ways of safeguarding biospheres. And it's also interesting to see that many of the slightly premature visions, I do think that settling the solar system in space is really worthwhile long run. But right now it's not maybe the most cost-effective way of safeguarding the Earth. But if we imagine Elon Musk settling Mars, what does he need to do that? Not just rockets. He needs to have enclosed biospheres that are very stable. He needs to have automated mining and manufacturing and recycling that is essentially 100% effective. He needs to have solar power that's really good. By that point, we don't need to settle Mars in many ways. We could actually do a lot of good stuff on Earth with the very same technology. There is also something else that's interesting here, and that is that many of the things I'm talking about are possibilities. They're not bound to happen. But intelligent beings like us, being an intelligent being means that we make possible things happen with a high probability. That is actually what intelligence is. If I want something to happen, I figure out a plan to make it happen. And then I poke the universe in various ways to set up this unlikely chain of events that generates the desired outcome. Whether that is ordering something online, or making a trap catch an animal in the jungle, or starting a social movement. We're not always good and reliable at this. But if we look around, we find that we're living in a highly improbable environment. This is not how the world would look if just the normal laws of probability and thermodynamics would rule. We're sharing this to some extent with all life, but we're even more long range than most life forms. And finally, of course, what I really care about is hope. We need to actually recognize that there is existential risk. It's dreadful. It's nightmare-inducing. But there is also existential hope. Things can turn out well. Things can turn out fantastically well. And I do think that we have potentially an enormously grand future. It might very well turn out that our post-human descendants inhabiting galaxies far away are going to be sighing and thinking, oh yes, back in the 21st century, they had the simple life. They had nothing to worry about. Yeah, some pandemics and nuclear wars and AI programs. We have some serious problems. But I think I'd rather have that future where the post-humans think that they have problems. Just as we think that we have dreadful problems compared to our ancestors who were starving in their caves, or their ancestors who were trying to figure out how to get nutrients in the primordial soups of Earth. I do think that we have a grand future ahead of us. I hope we have a grand future ahead of us, and I'm going to do my darndest and try to convince you to help me to make it grand. Thank you.
Thank you very much, Anders. Is there any short question previously to the coffee break? Or if you have a more important question, we can keep the question for the debate. Somebody want to ask anything? No? Okay. We have the coffee break and then we will have the next session of the workshop. Thank you.
Thank you. Yeah.
Hello again. This is the second session of our workshop, and the next speaker is Idoia Salazar. Idoia Salazar is founder and president of the Observatory of the Social and Ethical Impact of Artificial Intelligence, Odisseia, member of the team of experts of the Artificial Intelligence Observatory of the European Parliament. She is currently working on the configuration of the Artificial Intelligence Regulation Sandbox with the Spanish government. She is PhD professor at the CEU San Pablo University, specializing in ethics and regulation of artificial intelligence. She is the author of 4 books about the social impact of artificial intelligence, One of the latest are El algoritmo y yo, guía de convivencia entre seres humanos y artificiales, y el mito del algoritmo, cuentos y cuentas de la inteligencia artificial. She's an advisor for the Spain on the advisory board of the International Group on Artificial Intelligence, and a founding member of the Springer Journal Artificial Intelligence and Ethics, and a member of the Global Artificial Intelligence Ethics Consortium. Idoia, the floor is yours. Thank you very much.
Okay. Thank you very much, Antonio, for introducing me. And thank you for the organization for inviting me. It's a pleasure to be here. I'm not going to talk about the future, though our previous speakers really did a great job. It is like a fact that nowadays we are the ones that are inventing our own future. It is nowadays, this specific moment in which we really have to work very hard in order to be optimistic in our future. And it's not a matter of, it is very important to think ahead, but it's even more important to think about the many, many things that we still have to do nowadays. I'm going to talk about something that I consider that is not the future anymore. I'm going to talk about artificial intelligence, something that is all around us. And here, I'm going to show you how in the world that we live nowadays, it is very important, this tool. It is very important to know, all of us, absolutely all of us, what is artificial intelligence. And it's something that is not technical. I'm all the time saying these words. Artificial intelligence is not just a technical thing. It is very possible, all of us, to understand the impact of this technology. And it's not possible, but it's a need to understand this technology. I'm going to try to do so, to show you why I'm saying these things. I start with this question. Are we ready as society, really, to live in a world of data, to live in a world of artificial intelligence? We really live in, if we are like in a public, if we really look at the society in general, many of the things around think about artificial intelligence and robots as just part of a science fiction thing. They don't really get to know the difference between an artificial intelligence system and a robot. They really don't know what is happening with our data, with the data that all the devices that we have with us are doing. And the thing is that nowadays we live in a confusion, a society in which we don't know if some things that we see on the news, it is real and what is science fiction thing. That is a reality. We are living a great revolution nowadays. We could compare this revolution with the Industrial Revolution. At that time, it was a more physical revolution. We started to invent many physical things to augment us as humans, physically. And nowadays, we live in a world of data in which, like every device, many of the digital devices that we have with us really make us these devices keep all the data that we are generating, every movement that I do with my hands, or every movement that I do. If I just stop in front of a shop there, my smartwatch or my mobile phone is going to know how many seconds I have been spending in front of a shop for whatever. The thing is that we as consumers really we have the right to know what these companies, all these companies that at the end are the ones that are really keeping all of our data, is going to do with my data. Anyway, as I told before, during the Industrial Revolution, we invented all of these physical machines to augment ourselves physically. At that moment, it was a need. Really help us as humans to do things more efficiently in agriculture, in many fields in the industry. And nowadays, with all this data that we are generating all around us, we have not invented, because this is a thing of the 1950s, but we have really improved this technology in order to help us to augment ourselves, but mentally, but really to help us to deal with all this data that is around us. And it is a need because we physically, we don't have enough capacity really to deal with all this data that is around us. We really need these AI systems as a help to deal with all this data and really to create value from data. Something that nowadays is as I told you before, is a need. It's not something that we can think about, okay, are we going to use this tool or not? It's not something that we can choose about. Here you have, I am really saying several times these definitions of AI system as a tool, because we really have, all of our society, all humans, have to see this technology as a tool to help humans, ever as a substitution of humans. Artificial intelligence, it is a tool to help humans to do things better. The same as we have been dealing with all these things, we have been dealing with all the inventions that really humans have done during our whole history. We really try to invent several things in order to prosper as humanity. Nowadays, we really need these artificial intelligence systems in order to prosper ourselves, to make a good future. Here you can see a definition of artificial intelligence from the Real Academia Española, scientific discipline that deals with creating computer programs that execute operations comparable to those performed by humans' minds, as a learning or logical reasoning. If you see this, at the end, these AI systems, what is it? It is something, I don't know, of the future is something as a robot that is, I mean, there's like something that we could imagine, something that is not real. No, it's just a software. It's a software, but with specific peculiarities, with some similarities to humans. For example, decision-making and autonomy. These AI systems are able to decide, quote, by themselves. And they will be able to decide by themselves more than the future as humans. That is why maybe in our mind could be a little bit confusing. There were no technology before this that was able to do this. And there is a capacity that until now just have the humans. And for us as humans, we feel like a little bit confused with this. Just for you to just think a little bit more about this. This is like, for example, we as humans take all the data that is around us and our brain, inside of our brain, start dealing with all this data. We start, even if we don't notice it, and at the end we extract a conclusion. So we could make that similarity with these AI systems, but the thing is that this is a machine. This is not something, I mean, in a decision making, when we do that as humans, it's not that just we don't just process the data, we apply the context. For us, it's not the same to make a decision maybe in our family, than in our work, than in many other situations. And that the machine is not able to do that. And there is another thing. When we really make this decision, okay, we take into account all of these things. The machine itself is fed by many data, and if you don't really take care of the data that you are by which you are feeding the machine, at the end you are going to have bad decisions, bad conclusions. If you apply just that bad conclusion into something that is important to all of us, then we are going to have a problem. Okay? This is another similarity. Just imagine that we have something similar to, for example, a Thermomix. All of us know what is a Thermomix. If we give the Thermomix the ingredients that just the Thermomix is telling me to give, and good ingredients, at the end, the Thermomix work, and at the end, we are going to have like a very good food. But what happens if I give some of these ingredients that are not really good, that are, you know, or I don't give all the ingredients that the Thermomix need for that specific dish? Then the conclusions at my final plate is not going to be that good. So this is similar to this. I really see like that one of the worst thing about this big technology that I really think, as I told you, that is like the technology of the future, is that this thing around the decision making. I don't like that word, really, decision making in terms of when we talk about artificial intelligence. I prefer to change this word to conclusions. You know, for example, I have an AI system that helps me. I'm a human sources director to take a decision. So it's a help for me as a human sources director that is going to give me some more information, some conclusions, and I am the one, as director, that could apply the whole context, who is going to take the decision, finally the decision for this. So for me, it's going to save me a lot of time, and maybe it's going to give me like another point of view to complement my decision as human. Why? Because if I don't do that and I let the machine to make the conclusions, the decisions themselves, by themselves, then if I am wrong with my decision, what? Who is going to be responsible for that? The machine, that software? The same as, for example, I can give responsibilities to this bottle of water. So the director is going to be, the director of human sources is going to be responsible for the decisions, not the software. So we have to really work hard in that direction to change the decision making for the word of conclusions. So we have this, so that is, really we are having, that's why we are really having these difficulties in gaining confidence in AI. We have this whole, a lot of producers around this technology. We have these similarities to some things that the humans really used to do just us. And that's why for us, it's a little bit hard to work, to have confidence in AI. We have these machine taking decisions, as we said, machine bias. We have been plenty of bits of news that really are not very, very good. So that make us to feel not very much confidence. And then we have these producers, and there is another thing that I think that all of us agree that everything goes so fast, and we really need to work hard right now, I'm telling you, as I told you, to really try to kind of maybe put some limits for this, or maybe think a lot, as also philosophical, in a philosophical way, in order to order our priorities and work, I hope that in a good direction. Here you just have some of the news regarding the things that we didn't do well with these AI systems. Like, for example, this one that says, who is making sure that AI machines aren't racist? You know, that means that most of these titles really could maybe make us think that the ones that are really racist are these AI systems. Something that, as I told you, the bottle of water. Who is the one that is being racist? That is something that we have to start thinking. It's like very easy to give the blame to the machines, to this bottle of water. For us as humans, we are the ones that are biased many times, all the times. And nowadays we have these AI systems that do not have voice, but we are working hard in the in the natural language, but anyway, they really don't have like the power really to make to to maybe answer all of many times that we say this is the blame of the AI systems, and we have to realize that we still, as humans, are the ones that really need to keep really improving in our really taking care of the data in which we feed the machines, getting out all the variables that really make this system that bias. But the thing, as I told you, is we really have to focus on this, but also we still have to think a lot about ourselves and the way we are as humans. Another thing that makes us to be not very calm about these AI systems is that this, as you see here, will robots take away human jobs? Okay, I don't think that this is like a big deal, really. I mean, you could say, that is, what are you saying? Not really, you know, and that happened during the Industrial Revolution, that happened like in many periods of time. And what do we have, why are we like, really, like this is like a big deal nowadays? I really think that it could be like because of something that comes again from science fiction, and we see like pictures like this one, like taking the robot, like firing like a human. This is in our imagineering, like since a long time ago, and nowadays it's like possible quote, but. I don't think that it's going to be like quite different from other revolutions that we have before. Like, for example, Industrial Revolution, for example, during the period of the internet, when the internet came into our lives, there were like plenty of jobs that were disappearing, and there are many other jobs that were appearing. So what do we have to do? As humans, we really have to get out our comfort zone and start learning all the time. And that is the thing that we have to, like, it's not a thing of just, I mean, all of us have to work hard in this. Also the universities, also like in any educational system, we really have to change our educational system. It's not a matter of just having, working in the professional world, but this is a thing that we have to start really changing from the first infrastructure that we like the first steps since the schools, in the schools and all the universities really have to work hard in really changing all the way that we approach education, because we really need to get to be formed in new ways, not in these new jobs, but in the new abilities, in a way that we really have to get knowledge in every year now of our existence. This is another thing that makes us feel a little bit not very comfortable with these technologies. The possibility that these AI systems really make things that seems to us like science fiction, but it's not science fiction anymore. You know, these AI systems are able to replicate us in a very good way, even inventing new people that don't even exist. And all of these possibilities really make us think that this is not good. But I always say the same. The problem is not in the technology itself, but in the way we use the technology. So again, it's a problem of humans. It's not a problem of technology. There are some people that say, as I'm telling you, we as humans, we have commit like many mistakes, many errors. There are some people that say that maybe like a new AI president could run like maybe a country better than a human, or maybe we are going to have like better judges if we just have like an AI system working as a judge. If we really make this good, maybe we are going to get AI judge that maybe is not going up. There are possible bias if no counter bias. Okay, that is something that's not good, but if we take out all the bias from the data and really get to do a very good technology, maybe in the future, the AI judge could be a better, more objective than maybe a human judge. In my opinion, again, I really think that the AI systems are going to be like very helpful for judges or doctors or investigation. It is really a great help for all of these experts. And it's a need that these doctors, these AI systems, these judges maybe start using these AI tools to complement their decisions, not to substitute their decision. Okay, now I'm going to change a little bit and I'm going to focus just in businesses just for a while. We talk about all the possibilities of the AI systems. We're going to center ourselves in this because there are like great opportunities for all the business around, and it's not a matter of just a good thing, a good tool for just technological companies, but every company of every field they could use these AI systems and to improve the way that they deal with data. So there are like plenty of companies that are already using this technology in order, for example, for cost saving, customization of products and services based on massive data analysis, improves the efficiency of processes, energy saving, time saving, development of dangerous and high precision tasks, economic based on forecast on patterns of the future and not only the analysis of the past. This is very important. Also as assistance in decision making based on comprehensive and complex analysis. And there is another very important sentence which is down here, which is the AI system does not get tired, does not sleep, and works like 24 hours a day, like every day of the week. So that is something that for many companies like a plus. It's something really good. Really, I put that slide because in terms of personalization, it's like great. Just imagine like really the possibility to analyze every one of the movement of the people, of the customers. So if you do that, I mean, you are able really to, they are going to, people that uses, the companies that uses this technology are going to know every one of the customers even better than themselves, because we as customers do many things unconsciously. So we really have to be, all of our society really need to be more conscious of every step that we do, because that we make. Because if not, it could be like quite easy to be manipulated by these companies, you know. At the end, these AI systems is something that you put in that all these companies, I mean, it's a matter that like in the back of an AI system, there is a human, you know, and a company that is the one that is going to be processing this data and is going to make profit out of your data. Here, I'm repeating all the time, this sentence, but it's like very, very important nowadays. Collaboration, no substitutions. Okay, it is, I think it's the key. Here, you have like an app, which is called Babylon. I don't know if some of you know what is this. It's like a medical app. I mean, you can access it through the web. And it's in this website, you enter all your data, then maybe you have any disease. You can enter all the data of this disease, whatever happens to you. And this machine, this has an AI system. And this AI system is going to be learning about your data. Okay, of all of your questions, is going to be learning of all about all the questions with all the data that you're going to provide this machine, and also about And with your questions, if you give this machine more questions, the AI system is going to do it even better. And this app is being used in the United Kingdom and in many other countries in order to make the health system in the United Kingdom runs a little bit better, you know. So you are going to be able to ask these machines for small situations like small diseases. You could ask this AI system and you get an answer out of it, and that is like is a help for this sanitary system of the United Kingdom, but just a help for doctors, not a substitution for doctors. Again, for me, it's like this slide. It is important. It's one of the most important things. We have to stop like thinking about robots. We have to stop thinking about robots and science fiction thing when we talk about AI systems, and we have to again going to this. The human is at the center, and the AI system, it is a tool. And we have to keep, and we have this AI system we really have to, it is like when we look at the mirror and we are going to see all this is going to be translated into data, and we are going to feed the AI system with all the data that we are generating, and that is why maybe this is like we have like all the problems that we have in data with bias nowadays. I'm going to go because they are telling me that we are running out of time, so going very quickly through next slides. We already have been talking about that, about the different ethical problems that we have nowadays with these AI systems. As I told you, I really think that we have to think about all the different words that we have here, but again, I think that we still have to think about the ethics of humans and not that much about the ethics of artificial intelligence. We have to talk about fairness. We have to think about fairness, transparency, reliability, and safety, privacy and security, accountability, inclusiveness. But the ones that have to be thinking about that are the people that are really using these AI systems. We have to take care of the data. We have to be transparent in our decisions. We also have to work in the transparencies of the AI system, but we as humans have to make all of this. We have to minimize this risk, doing some things, for example, audits of AI algorithms by private companies, organizations, también national work in national certifications, training public administrations on the real impact of AI and how to promote this technology, minimizing risk. We have to, another thing very important, train and the society. Really, we have to educate society in really the real impact of artificial intelligence. I mean, it's not, and I'm going to end here because I think we don't have like more time, but for me is one of the most important things that we have to focus nowadays is in the education of society, because society has the right to know what all the companies that manage all this data are going to be doing with us. With all our data. If we don't really train society, if we don't really educate society, it's going to be like quite easy, as I said, to be manipulated, and it's going to be, and that is unconsciously, and that is like I think one of the great bad things that we are going to find in the future if we don't work hard in the education. That is something of the public administration, is something that we have to work also from the private sector as something that has to be like doing together. Thank you very much. I really hope that this is a great technology, but we really still have to work a lot. So we really get to manage to find the right way to to go and to follow the right path. Thank you so much.
Thank you very much. Idoia. Well, Idoia unfortunately won't be able to stay for the final debate, so if you have some question, now is the moment. No question, no comment? Well, thank you.
No.
Thank you very much.
Yes, okay.
We are listening a lot of computer art. I wanted to ask you about computer art, for example, music done by artificial intelligence or paintings, but for example, for the case of music, do you think there can be some kind of machine creativity? What is the, you have been talking of collaboration all the time. Where would the collaboration be in that case? Do you think it's just the taste of the listener that is going to modulate what the machine does, or how would you say that?
Okay, so thank you so much for the question. Okay, I really think that there is, I mean, nowadays, as you said, there are like an AI system used in the art industry to create so many, even a new, really pictures, like great pictures that are not created by humans. And also to complement some melodies that done by like great artists as Beethoven and another artist. So I really think that as you see, as you saw in my slides, there is possible to create images out of nothing. I mean, the AI system is able to create like people that do not exist. It is possible that this AI system even create art that haven't existed before. And that is like bad, good or bad. I think that is different. It's not good or bad. I think that next generations are going to see like quite different world, and for them it's going to be like quite normal to see melodies or maybe books created by machines. And for them, it's not going to be like in the future, it's not going to be like good or bad. It's a different thing. It has been like something created by a machine. You know that nowadays there are like some pictures created by, it was Bellamy, that was created by a machine and was sold in Sotheby's by, I don't know, thousands and thousands of euros, you know? So that doesn't mean that the work created by the machine is going to be like something that is not expensive or is not worth it, you know? So maybe it could happen, but just it's an imagination. Maybe in the future, maybe it's going to be like quite similar that in the Industrial Revolution. If you like create, if these AI systems are able to create, I don't know, 100 of books in 5 minutes, maybe that the book is going to be very cheap for all of us, and we are going to be able to have a cheaper access to culture, you know. But there's something that just for talking, because I don't know what's going to happen in the future. But I really think that our perspective nowadays might be different from the one that maybe our kids of the future are going to have. I really think that for them it's like they are going to have a different approach to the art, and it's not a bad or wrong, but it's different.
Thank you.
Okay, thank you very much, Idoia.
Okay, thank you.
Our next speaker is Manuel González Bedia. He's an associate professor at the University of Zaragoza. He was a member of the advisor in the cabinet of the Minister of Science, Innovation and Universities. And since March of 2020, he is Deputy Director General of University Research Activity in the Ministry of Universities, a member of the Research Coordination Commission in this ministry. He holds a bachelor's degree in physics, a master in social studies of science and technology, and a PhD in computer science, extraordinary prize, from the University of Salamanca. He worked as a consultant in technology management and innovation at the Cotec Foundation, and since 2000 as a lecturer and research at the University of Salamanca, Complutense, Carlos III de Madrid, Edinburgh, and Sussex. His research has mainly focused on the development of computational models applied to the understanding and modeling of cognitive processes. He is a member of the European Society for the Advancement of Artificial Cognitive Systems and co-founder of the Spanish Network of Cognitive Sciences. In 2019, he was the driving force behind the Zaragoza Declaration, a manifesto drawn up by experts and members of civil society to call for a code of ethics for engineering in the field of smart technologies. So thank you for coming, Manuel, and the floor is yours.
Okay, thank you very much for the invitation. I'm very glad to be here. In order to fix the message and the time, I have prepared some notes to give the talk. As Antonio said, my name is Manuel González Bedia. I'm reader in computer science in University of Zaragoza, but let me check. But I am currently working on the design of research and development policies with interest in how to analyze the impact of artificial intelligence in general in society, in democracies and in society. Okay, I have prepared a talk about the fundamental knowledge that all of you should know in order to have a realistic picture about artificial intelligence in this last wave of artificial intelligence that we see in media. No? In general terms, the things that one listens in media about artificial intelligence is simplified and unrealistic. And I think that in order to work in problems of social impact of digital technologies and to understand how these technologies could affect collective problems and in democracies, it's necessary to have a more realistic idea of what it can do and what it will never do. So let's start with the first message is that if I would like to know what's the popular view of artificial intelligence, we have several messages that we receive from the media. I find three main characteristics. On the one hand, there are a huge amount of news about successful applications. Almost every day, artificial intelligence is successfully used in any problems, in medicine, mobility, but always successful points are remarked, but failures, mistakes, or wrong performance are not well known. This is the first idea. The second one, more related to the politics domain, is that artificial intelligence is mandatory in the current political roadmap. Since 2018, we have almost 55 national strategies and 85 memorandum about social impact or how to create a more artificial intelligent human center. There are several economical reports about labor automation from supranational organisms. But in general, the visions about the future is that artificial intelligence will take us to an or an utopian places, we will not need to work, we will have enhanced cognitive skills as cyborgs, or in the other side, artificial intelligence will drive us to a dystopian scenarios. Singularity is coming, and we will be the slaves of super intelligent machines. Everything points to artificial intelligence as a new revolution, and in the good sense, as the chicken of the golden eggs. However, my message is that this is not the case. Most of these messages are fallacies. Systems that are promoted as autonomous have thousands of people behind them manually labeling pictures, for example. Most national strategies are simply useless documents. Many of them are similar, the documents have been produced by, for example, private companies, copy and paste. Ethics and artificial intelligence, in some sense, are proposals that hide industrial interests against restrictive regulations. Economical reports about labor automations are not carried. So many of the future scenarios are more closer to science fiction than reality. As there is too much confusion and too much noise, so we need some technical knowledge in order to clarify the artificial intelligence reality. So the idea is that from a technical point of view, and to understand it, we need a bit of history. For centuries, thinking about human intelligence has been made by philosophers, Plato, Descartes, Hume, Kant, that were interested in how we are able to understand the world. But at the beginning of the 20th century, there was a naturalistic turn in the way as scientists, researchers interested in natural science started to show interest about how our mind works. And we can find two different perspectives in this point. In one side, experimental psychology that propose some cognitive functions, memory, reasoning, etc., to understand intelligent behavior, or on the other side, neuroscience, by analyzing the neural processes in the brain and the nervous systems, try to understand also intelligent behavior. In the middle of the 20th century, these visions were combined with the typical knowledge of engineering and mathematics, adding a new goal, not only to understand intelligence, but to replicate it by machines. The idea is that a way of understanding something is by creating it. If you replicate something, you have understood how it works. Then we have a community named cybernetists, later connectionists, full of people interested in modeling neural networks by mathematicians and electronic, studying and quantifying information processes. This methodology is clearly bottom-up. They model the basic interactions from which intelligence emerges. And we have other community named computationalists with researchers interested in modeling higher cognitive skills and abilities such as reasoning, language, using mathematical tools, other mathematical tools. And they assume cognitive categories and propose the pathways between them. The idea is that both communities lived peacefully together around 1956, when the things began to change. To understand a little more about how history evolved, let us explain in more detail the main technical characteristics about these approaches. Computationalist people understand intelligence essentially as reasoning. The way of working is to encode structures of reasoning into algorithms. For example, Boolean logic sentences as if X true and Y false, then X and Y equal false. Main applications are in problem solving or in modeling higher skills such as planning and language production. connectionist people proposed, in opposition to the compositionalist ones, a way of viewing an intelligent system as a no model. What does it mean? They don't want to capture aspects of the intelligence and codify them in algorithms. The idea is to allow that open models with parameters to be fixed are able to structure through continuous trial and error cycles, where the parameters change in the direction of minimizing errors, mistakes. Main applications are in clustering problems, pattern recognitions, etc. To better understand this, let's see an example. We have a picture of a cat. The color for each pixel is connected to a neuron, artificial neuron. The input value is aggregated with the free parameters and goes through a filter with outputs 1 or 0, yes or not. The goal is to obtain parameter values that, in the case we have pictures of a cat, we get a 1. And if it is a dog, for example, we get a 0. How is it done? By training with a database of a cat and by supervising the performance of the system and correcting the mistakes. And when the process finishes, we have a cat recognizer. If a similar cat to the previous one appears, the system is able to generate an output with values 1. The idea is that the network will be able to generate the same outputs for similar pictures. So, let's go to the history again. We are in 1956, and the first summer of artificial intelligence belonged to the computationalists. With summer, we want to say that they attract the better expectatives and the most funding. For similar reason, they are the first one to succeed in taxi generate interest. For example, they develop logical reasoners. As we have said, they understand intelligence as reasoning, so the models that they create are universal models. The artificial intelligence algorithms capture structures with independence of the domain. But after 20 years of work, they got a lot of fails and empty promises. So, in 1973, the first winter comes when a big amount of expectation not met. And at this moment, the Lytle report, a report of the British government analyzing years of funding in artificial intelligence, criticized very strong the scientific work developed by the artificial intelligence community. So funding was reduced and many centers and projects were closed. Was then a good opportunity for the connectionists to be the leaders of the area? In the past few years, there had been some progress, as for example, they have been found a technical way to train more complex and multi-layered networks called perceptrons, and this was the famous backpropagation algorithm. And also, they have been elaborated more sophisticated and improved applications, especially in the field of computer vision. However, this period was also a time of intense political play, because computationalists started a scientific campaign to evaluate interest of the results that had been produced years and years of working with artificial neural networks. So, computationalists there were the winners against maintaining the leaderships in the context on the artificial intelligence. And a second summer began. Computationalists used the same point of view than before, intelligence reasoning, but to overcome the previous limitations, they make the intelligent system with dependence of domains. They capture and made the models of reasoning of an engineer, of a doctor in general, of an expert. This was the period of the expert system, or also called the knowledge-based system. However, again, objectives and predictions fail again. And the second winter of the artificial intelligence came. The idea that the computationalist approach to artificial intelligence failed was consolidated. This approach only had been able to find solutions to toy problems. Again, the connectionists had a new opportunity to be the leaders in the area, and this time they did so. So, in 2000, the world had changed a lot since the second summer began and many progress in the neural network field had been made. For example, first, the boom of internet that generated a huge amount of technical innovations. For example, both distributed algorithms and data hosting service in the cloud, improving and allowing the processes of large amounts of data in distributed frameworks. In addition, computers increased computing power, so that new and efficient tools appear to execute algorithms in very large databases. In the same sense, artificial neural networks increases in diversity. There were probabilistic networks, Bayesian networks, and some of them called convolutional networks that present a very interesting properties. In the case of a typical artificial neural network, a picture of a cat was encoded in the whole set of parameters values, but and distributed in the topological structure of the network. So the encoding is modularized. But now with convolutional networks, it's possible to identify what are the parameters that encode the whiskers of the cat, the ears of the cat, the eyes of the cat. And why this is an interesting property? Because these networks are able to recognize patterns more efficiently by exploiting compositional properties. If you recognize cats, cat whiskers, cat ears, cat eyes, and lions, lions' bodies, lions' teeth, you are also able to recognize tigers without training. Yeah, this is the idea. So, during this time, an interesting technique had been created to improve this training and learning processes by eliminating the need for a human to supervise and correct errors. The idea consisted in putting two networks to work together. One network is learning and the other is teaching, and correcting the first one. These are called generative antagonistic networks, and in this case, the increase of the learning processes was very impressive. With the uselessness of a human supervisor, machine learning techniques were also improved. Okay, so in 2012, a new type of artificial neural networks was presented with a performance in pattern recognition with several orders of magnitude better over the state of the art. It was an artificial convolutional network plus machine learning through generative antagonistic network mechanisms, huge computational capacity, and the use of huge database. And this new mix of technicals was called deep learning system, and it was the beginning of the third summer of the artificial intelligence. So since 2012, we have a high level of success in the application of deep learning in different domains, medicine, physics. We have machines that are able to win the world's best player in Go, AlphaGo, an incredible and disruptive advancement in machine translation, for example. Compositionally generative antagonist networks have allowed us to create new computer applications, for example, in the creation of realistic pictures that they know exist. So we are living in a time of enormous enthusiasm, but these technologies show fundamental problems. They are, for them, they are selfish systems in the sense that they need a lot of data. They are systems able to predict future behaviors by extrapolating the past, but they don't explain what happens. They only are able to make predictions, and it means that they cannot anticipate bifurcation or drastic changes. For example, a person who buys different things than before. And they are systems very sensitive to attacks. After a system has been trained with millions of data, can completely break the functionality if an adversative case is introduced as an input. That is a single picture designed specifically with the goal of breaking down the whole performance of the system. And finally, it's not completely clear why these systems work and where the limits are. So, the idea is that these problems don't depend on computational power or data quality. They are constitutive to the deep learning techniques. Okay, so what are scientists doing to solve these problems? To avoid the selfishness, they are trying to find alternative computer techniques that obtain the same performance but using a small amount of data. This is a line of research. To overcome predictions, there are a group of researchers working in the way of incorporating mechanisms of explicability. To overcome the sensitivity to attacks, there are investigations in finding robustness techniques. And to understand why these systems work, there are mathematicians trying to get what mathematical concepts are behind this. And this is the work in progress at the moment. The question now is, this is the real and current domain situation, and the question now is then, if we are approaching to the beginning of another winter of artificial intelligence. And in order to find an answer, we show some facts about artificial intelligence today. It exists an exponential growth of papers in artificial intelligence in the last few years. Since 2018, we have the 80% of all the artificial intelligence papers published in the history of the discipline. However, these applications that are being developed don't present a significant increase of productivity. The other thing is that current leaders are private technological companies and not now academic institutions. The 20% of all the papers that are published every year are elaborated by only 4 companies: Google, Microsoft, Facebook, or Meta, and IBM. There is a growing literature about the privatization of artificial intelligence research. There are a concentration of researching companies together with universities that collaborate with companies, but increasing the overlap between academic goals and industrial interest. And the last message is there is a diminution and lack of diversity in artificial intelligence in the last decade. Private sector companies have lower levels of thematic diversity in the research profiles, and it's affecting also to the academia. So, in order to conclude, what can learn from the history? First, that the top-down methodology for building intelligent systems failed so far. In other words, researchers have been unable to generate intelligence by absolutely codifying all the knowledge that humans need to solve a task. That is, there are skills and ways of processing information that are embodied, as for example, skills as cycling or dancing, that are not able to be modeled by algorithms. And the second one is that the bottom-up methodology for building intelligent systems has been successful so far. But we don't know if we will be able to overcome very fundamental limitations. These technicals are not able to produce explicability models, and these technicals doesn't include anything essential different from the knowledge we have in 1980s, only that today we have a huge computational power. So, well, I'm going this one. So, as a summary, well, the final idea is that maybe we are inside the scaling hypothesis that assumes that we can solve every problem in artificial intelligence, only increasing the level of data. No? And at this point, I agree with Gary Marcus, that is a well-known quantitative scientist that says expecting artificial intelligence system to acquire superior cognitive capabilities by adding more data is like believing that a plane that flies faster will eventually lay an egg. So, and now finally, as a summary, three take-home message. In order to work about the impact of artificial intelligence, about how artificial intelligence affects our societies, we need to get basic but strict technical knowledge. For example, artificial intelligence is a research program that tries to replicate intelligence with machines. While machine learning, big data, or deep learning are data processing techniques. They are methodologies that try to get the goals of the artificial intelligence program, but they are different concepts. We had to avoid hyped message. Artificial intelligence will not do everything it's said to do. We have to make realistic analysis. In some cases, artificial intelligence is doing more than was thought possible only a few years ago. Okay. That's all. Thank you very much.
Thank you very much, Manuel. Manuel won't be able to stay to the debate either. So if you have a question or a comment, this is the moment now. I have a question, if I may.
Yeah.
What is your opinion about the possibility to create, in the next future, general artificial intelligence?
I think that if we continue living in this current approach with these methodologies, I think that there are constitutive limits to obtain this general intelligence. But maybe there are different lines of research. For example, understanding better how our mind works and extracting ideas about this as a cognitive artificial intelligence, or designing new mathematical tools that we don't have now. Maybe with these lines or the mix of these lines, we can obtain or we can go abroad the limits that we have now.
So you are skeptical about the possibility of the singularity, for example?
Oh, yeah, for sure.
Some questions, some comments? There?
How do you think that we can solve the big company problem in the AI field?
The big company's problem?
Yeah, the Facebook, Google.
Well, private companies have got their interests, but now they have the best infrastructures, the best ways to connect with academic institutions to capture the best researchers. So the problem is that the agenda of interest is marketed by companies, by private companies. I think that this is a very important point, that the diversity in artificial intelligence has increased a lot in one decade. And the reason is because private companies are the leaders now, fixing the goals, fixing the interest. So I think this is a big problem, and public power have to go to change or to turn the wheel. Yeah.
More investment, or
and more investment, and in different goals, not instrumental goals, not short-term goals. Preparing for a next and a future artificial intelligence.
Okay. Thank you.
More questions? No? Okay. Let's thank again to Manuel. Thank you very much.
Thank you.
So here we are. We have the three speakers, David, Irene, and Anders. And the idea was to finish with a debate. Although Anders doesn't understand, I would like to encourage anyone who wants to ask in Spanish to do it, because I think it's possible to mix both languages in this session if it's necessary. So, who wants to start? Maybe Antonio can start to ask a question. Yes.
Well, I have some questions, yes, because all the talk was really very interesting. Well, I can start with Anders. Anders, and you wrote some years ago very influential papers about the possibility, in order to prevent some existential risks, for example, climate change, but also the consumption of the natural resources and so. Not only to make geoengineering, but also to apply the engineering to human beings. For example, reducing the size of our species, the size of the human beings. So I would like to ask you, what is your position now? And if you, for example, if you think that geoengineering is now a more realistic possibility, and also if you see that the technological possibility to modify genetically the human being is near now and is possible, and so. What do you think now about the topic?
So that little paper about human engineering is my most controversial paper ever. And I must admit, it's kind of academic trolling. It was partially, from my side, trying to demonstrate that environmental ethics and medical ethics didn't work well together, and that was a problem here. So I did not take my proposal that we should genetically engineer our kids to be small and see in the darkness and be allergic to meat very seriously. It was mostly to make a point, but a lot of people got very, very upset about it. So I got way more papers talking about it, usually saying that's a very stupid idea and nobody should waste their time on this. So they wrote papers about it instead of working on something sensible. But the argument we made in the paper is that normally when we think about fixing climate change, we think about upstream and downstream responses. You could try to fix it upstream by changing our economy. Or we could make the carbon emissions lower. Or we could try to do geoengineering to fix the effects of the world. Or we could just adapt to them. The human engineering paper was working on the totally most extreme upstream issue. What if we fix that? And I think in practice that's not very likely go. Many people criticize geoengineering because it doesn't fix things upstream. And in some situations, I think that is a correct critique. In the years since we wrote that paper, both we got CRISPR-Cas9 making human engineering actually much more doable, but we also have seen that people have been investigating geoengineering much more closely. And one of the most common traits I found among people studying geoengineering is that they're not in favor of it. They understand that it's doable, but the drawbacks and risks are actually quite sizable. So they are often very worried about it. Now, the interesting thing is geoengineering studies were not done that much in the 1990s when it was the early days. Partially because the environmental movement and the people involved in climate hated the idea already from the start and said, if you even investigate that question, people will say there is a solution instead of fixing the economy. So there was no funding. You were not really allowed to work on it. Later, that taboo broke, and indeed the people investigating finding that this is probably not a great idea. If I had done that in the 90s, we would actually have learned it was not a great idea much earlier and been able to say that, okay, other adaptations are more necessary. So I think the moral of the story is something like, you want to figure out things about what are useful and not so useful interventions as early on. And also when you do academic trolling, be sure to generate more light than heat. In this case, I got more people upset about it, sometimes amusingly so. People wrote satirical poems about the paper, which is very amusing. But I do think that there is an interesting challenge of where do you do your fixes for a problem. Upstream is sometimes good, but maybe you can't go too far upstream. Sometimes adaptation is simple and stupid, but might be also much more doable than even fixing the economy.
Thank you. And there's more questions, or would you like to ask a question, Maria? Yes.
A question for David. So. Regarding predictions in climate change, for instance, you show that the weather in Madrid would be the same as Marrakesh, but other predictions, if the Gulf current breaks, is that we will have actually a colder weather. So maybe I'm not informed sufficiently, but I mean, I think there are so many things that could happen that I mean, which is your view on this?
Yes, that's a great question, right? Because we used to think on terms of warming when it comes to climate change. Can you hear me? Yes?
Yes.
But it's not only that. As you mentioned, there are other kind of possibilities for the future. They are becoming closer and closer to us. So I remember when I was part of the University of Oxford, that was already 15 years ago, we got access to the first climate change scenario based on a new glacial age for Europe as a consequence of the Gulf Stream current weakening till this basically disappears. So all this hot air and water coming from the Caribbean Sea that makes life possible in Europe will have a massive impact, right? You think that Madrid is at the same latitude as New York. Copenhagen, the latitude of Copenhagen, no one lives in Canada. It's impossible to live there. So at that moment, and it was already 15 years ago, the probability of this happening in the next 500 years was only 1%. I don't know the recent estimates, and I say it's much closer. Still maybe not as likely as other kind of scenarios, but if we keep warming and warming the planet, at some point, we will have a new glacial age in Europe, most likely. At that moment, this scenario was related to a study of the UK government in which they were thinking how many nuclear power plants they will need to build in UK to keep people alive and having food under a new ice age. And they were estimating between 20 and 30 new nuclear power plants to survive in UK. So this is kind of scary when we think on those things. But it's not the first time we see the Gulf Stream current like weakening and having a massive impact. And this is also an exercise that I do with my students. We now are just thinking in terms in which people from the warmer countries come into Europe and migrate because they have droughts and they have many problems in their own countries related to the environment. Might be a time in which Europeans will need to migrate to Africa because life will not be possible here, right? And it is kind of eye-opening for many of us about we're just one humanity, and the future can be good for us, but can be also really bad for us. And that's one of the most terrifying scenarios for Europe, is a new glacial age. And it's not likely to happen in the next 100 years, but if we think a bit longer term, in the next 500 years, we can be close to that.
There was a paper last week that I read in the New York Times. They were commenting the paper, and in the following few decades, it was predicting that the current would be interrupted, not permanently interrupted, by certain periods of interruption. That was the last week paper.
I would just like point out, of course, as a Scandinavian, I'm very concerned about glaciation. When I grew up in the 70s, my dad, who was about as pessimistic as I'm optimistic, was explaining that the consensus among climate researchers was we're approaching a new ice age. But he was careful. He pointed out there are dissidents saying that the carbon dioxide is going to cause global warming. And indeed, it turned out that the 1970s models about the imminent ice age were wrong. But the interesting thing is we're living during an ice age. We're living in an interglacial inside an ice age. And the total ice age is going to last for several more million years. So we're going to, even if we return the atmosphere to normal, we're still going to have to deal with this ice eventually. It's probably going to be some tens of thousands of years, but eventually. So taking the long-term perspective, we should probably make sure Africa likes us.
We have a question, yeah?
Thank you all for your long-term view on all these subjects combined. I enjoyed a lot all the talks. I would like to ask you globally, to all of you, what can be done in order for the general people to understand these messages that are so important and somehow they seem to be diluted in the context of other less important messages. For example, we see that nowadays, or this week, the soccer World Cup has full attention from many people. But then important messages like this have a very short latency. So of course, people just understand these messages, but they are in their mind for only, well, a very short time. And the second question is what we can do for politicians to take this seriously in the long term, because we see that they use these messages when they are convenient for them for the very short term, but the policies are always like that, short term only. Thank you.
Thank you very much for the question. Can you hear me? Yeah. I really think there is a growing awareness, as I state in my talk, among the people, so we are concerned. Of course, not everybody at the same level. And there are also like many factors, like uncertainty make us think like we don't know what is going to happen in the future. So these play a role and demotivate people to take responsibility, like in the individual sphere. I also think that who has more power has more responsibility. And in this sense, of course, institutions, but with institutions, I also mean sharing institutional responsibility. Institution is not an entity abstract that is there. We are here as individuals, no? Like the institutional responsibility is a shared responsibility. But the organizations, the collectives, the big institutions have more power also to move things, more economical resources, and strategies to change things. So there are many factors why they don't do that, even though at the same time they take some steps towards, as I also show in my presentation. But there are, of course, like economical lobbyists, as I don't know, the meat, lobbyists of the energy, lobbyists that influence politics and the politicians' interest. What we can do, that's like the question of the million, no? Like what we can do to change that. I think we should like increase and increment debate as much as we can, and include as much as we can interests of everyone, not just of few. So to expand the forum of discussion and the debate. Also that the way in we communicate scientists, for instance, it was an important task during the pandemics, how scientists communicated to the people what is going on, no? The facts, no? the science facts that they're analyzing and the data. So how we communicate that to everybody so that everybody can feel that understand what is going on and feel involved in the debate. I don't know, you want to...
Yeah, I think other important aspect might be education. And this starts with kids when they're small. I mean, one of the big paradox here, those kids are living in the maybe most technological society ever. At the same time, they ignore how technology works. And that's also not a really good thing, right? In the same manner for understanding what biodiversity means for their lives. And maybe higher investment on education programs in primary schools and high schools about what are the main challenges, right, for societies. I think that might be also other way to go. A second way to go maybe is to have a closer contact between academia and politicians. I don't know how it works in Spain, because many years ago I don't live here, but in Denmark the Folketing is the parliament. It's very usual to have scientists going every week to provide advice straight to the parliament. Also having scientists being politicians. So a colleague of mine from Oxford now is member of the House of Lords. So she's going to be in charge of reviewing the legislation in UK when it comes to nature. It's good that some of these politicians are also scientists, that they can have technical opinion, but also a strong influence of the outputs. So I think might be different ways to work with like that.
Another aspect, and this is closely linked to education, is being able to take perspectives on different timescales. Learning that everything is connected is important, but you also need to roughly understand the kinds of connections that exist. There is a movement in teaching history called Big History, pioneered by the Australian historian David Christian. And the idea there is that history is of course built on top of paleontology and archaeology, which is actually built on top of evolutionary biology, which is built on top of geology, which is built on top of astronomy. So instead of teaching these things as different topics, you should actually teach people about the history of the universe. This is roughly how the Earth formed. And this is why we have the geology we have, which is shaping the history of biology on Earth, which is creating the ecosystems where we evolved, and that is then leads all the way over to history. The point here is you can take different lenses. You can look at the very long term or the less long term. And I think this is useful for going forward, for thinking about the future. I'm very interested in rapid technological development, including the possibility of technological singularity, which I think might be possible or might not. Certainly things are moving fast now. But my enormous books, the book I'm writing about long-term future stretches literally trillions of years in the future. It's useful to be able to zoom out and then zoom back in and think about that very long-term perspective. What does that mean that I personally should be doing next Tuesday? And I think this is a skill that we need to be taught. This is a skill we want to have part of our culture.
Well, I have two short questions. I think at least are short. One is for David. What do you think about the extinction of the species, the possibility of rewilding, but not only rewilding, even the possibility to resurrect extinct species in the future? And the other question is for Anders and for Irene. One of these central ideas of long-termism is that, you have mentioned that, is that the future generation have the same right, deserve the same respect, ethical respect, than the present generation. I think that there is a long distance between accept, for example, the Hans Jonas imperative, act in a way that your action help to preserve the life in the earth, and even to consider that we must respect the next generation, the grandchildren's generation, for example. But I think it's a little bit counterintuitive. It's counter the ethical intuition to think that hypothetical people in the long future deserve the same respect than the people in the present days. That are my questions. Yeah. Thank you.
Thank you. I love that question. Rewilding is one of my favorite questions. I'm usually a person that has criticized rewilding quite a lot as a useful conservation approach. I didn't make many friends because of saying that. But if we live in a world in which we are moving species around, there are thousands of invasive species. The idea of bringing new species to countries, species like in Denmark, they are thinking about maybe bringing back elephants, because 130,000 ago they were there, and that maybe we can bring functions back in the ecosystems. I think this idea doesn't make much sense, because Denmark today is nothing have to do with the Danish landscapes 130,000 years ago, right? Imagine trying to introduce European bison in Spain, and now we have this issue. And we have talking to people in the ministry and other places. We have in the Iberian Peninsula really fragile fauna that is the result of evolution and other aspects. We never had European bison before. Here, what are the risks and the consequences of introducing a species that never been in a country? I mean, years ago, they decided that the beavers will be really positive for Patagonian ecosystems. Happened in the 60s. They introduced beavers there, thinking they will improve nature. The beavers were really happy in Patagonia, at the point that they grow so much that they start to build massive dams. They desiccate rivers downstreams. They kill the forest downstreams, and all the species living there. Then there are so many beavers in Patagonia that you still can make money by going there and take your rifle and kill them, because the Chilean government has no money enough to eradicate this. So I think we need to be really careful when we think on rewilding. I know it's becoming a really popular term in Europe and in US, and all of us will have this mythical view of the wolves coming back to Yellowstone. It's a myth. It doesn't work like that. And so I am a proponent of more classic conservation approaches, in which we have European red listing for habitats, for example, or for a species, right? The wolf is not coming back thanks to any rewilding experiment. The wolf coming back across Europe is the result of 50 years of habitat directive and red listing, right? And I really don't like when colleagues of mine try to use this term and to try to say that this approach is benefiting nature. I see this not as a really good scholarship. Then the de-extinction, and I work with people on ancient genomics and ancient DNA. My colleagues at DNA, like SKBS Leff and others, that they are able to do these magical things with ancient molecules, and the reality is a fiction. Our ability to de-extinct a woolly mammoth is just fiction. We might be able maybe to reconstruct some specific traits, like having an Asian elephant with hair, because we can do editing, gene editing, right? But that's not a woolly mammoth, it's still a Asian elephant, right? We have similar problems with the rhinos. I don't remember now, it was the black rhino, where 3 individuals of the northern population, they have this program in which, by using gene editing and other approaches, they try to make more rhinos. The problem with these kind of approaches are two, then funds for conservation are limited. If we start spending funds on these kind of actions, we are gonna remove those money for protecting other habitats. Second, it doesn't matter how many of these rhinos you can create. If you don't stop the threats, they will disappear again. We need to understand the threats in Africa, why people hunt rhinos. Because poverty. People need to survive somehow, right? So if you don't stop the threats, it doesn't matter how many rhinos we create in a lab, they will keep disappearing. So thanks for the question. It's a topic that I really like to discuss about.
Should I start?
Thank you, Antonio. It's a very, very good question, and give me the space to explain something I took as an assumption, but because it was a short presentation, but I'm really happy to talk more about it. I departed from the idea that people in the future have the same moral relevance than our contemporaries. And why is that? Why is that? In the literature of intergenerational justice, the most common approach is the one that says that we have a concern for next generations, 2 generations. This is Derek Parfit, Hans Jonas. It's Rawls, in John Rawls we also find this, Avner Duchalit, Janet Thompson. This is the most common approach. Why? Because we have a sentiment, a natural sentiment towards the people that are close to us. And in this way you can build solidarity. Not that I don't like, but I prefer responsibility because solidarity is, comes from the will. No, it's something voluntarily, and responsibility, as I approach and I build this concept, is to answer, is responder, is to answer to a fragility that we have created. So it poses obligations in us. So this is kind of the mechanism to care about future generations in a chain, kind of a chain, no? We care for next generations, so for our children, grandchildren, they will care for the children. But what happens with the effects of our actions that are in 1,000 years? If you depart from a sentiment, what happens if this sentiment doesn't exist? And there are effects that are, I mean, nuclear waste is going to be in 1,000 years, so right? So if we just focus in next generations, that doesn't ensure, or doesn't make us feel sure that the very remote and future generations won't live effects and consequences of our actions today. And this is the second aspect, if people who live now very far away from us, in other countries, have the same moral relevance that we have, this is the problem of global justice, is in the space. So people beyond our borders, they are as important as we are. Why people who live also in distance, but not space, but temporal, have less relevance or are less important? As I understand intergenerational justice, as a kind of global justice, space and time like play. I like to situate the problem in the same terms. So we care about people that don't live with us in our inner circle, because we should care for people who will live in the future.
That is also usually how I motivate it. Usually I point out that, well, Einstein demonstrated that space and time are basically 2 sides of the same coin. So it doesn't make sense in an Einsteinian universe to treat future people and distant people differently. But there is an important difference about the far future people, and that is that we're much more uncertain about them. So there is this big discussion about discount rates in economics. Normally, we care about sources of wealth and money less if we're further away into the future than we're present. And that makes sense economically to say that, something expensive far in the future is worth less to me right now than something that is much closer. But there is also a lively debate saying this is totally the wrong thing to do about human lives or other source of moral good. It might make sense to do about money and economic value, but it doesn't make sense to discount a future life even if it's very far away. However, there is another reason to be a bit careful about the future, and that is uncertainty. We don't know who these people are. That shouldn't affect our moral judgments too much. But we might not even know if they are around. right now, I might choose to have a child or not. So I might affect what people exist in future generations. We might do things like genetic engineering that actually change who they are. And they might, of course, do a lot of other things, which means that the further we go ahead, the more problematic it becomes to know who they are and what they want and what they would have desired from us. But that still leaves a pretty good set of guesses. We have probably good reason to believe that they would like to be alive, that they would like to have a nice environment, that they would like to have resources and options for the future. So hypothetical people are people too, in my opinion. However, in normal debates like this, people are much more comfortable to know about the next few generations because we're pretty certain they are around and what they are going to be about. While the post-humans in a few trillion years, they might be so alien and might want so alien things that we actually don't have a good reason to care for them, and vice versa. I still think there are other arguments that binds us in this enormous, vast project of humanity together. You can use non-consequentialist arguments saying, yeah, but we might eventually end up as those far future post-humans with their strange goals. But if every step along the way was something we felt like, okay, we're learning, we're growing morally, we're making choices, sometimes unwise choices, but learning from it, and eventually developing into something else, that might just be like a child growing up. My childhood self might not approve of everything I do and think today, just as I might very much like a middle-aged man looking back and smile at how stupid I was when I was a kid. But I might still acknowledge that, yeah, that was me, and that kid is part of who I became. And maybe when I'm 100 years old, I'm having very conservative views that I don't endorse right now. But I might still say, yeah, but I developed those in a valid way. We might want humanity to be able to do that in the same way, without any abrupt breaks, etc. So I do think we have multiple reasons to care about future generations. Some of them consequentialist, some of them non-consequentialist. And I think uncertainty is the big issue here that has come up in many of the questions. We don't know our climate models very well. We don't know if we're going to have a frozen Europe or a hot Europe. But we should probably plan for both. A hot Europe looks likelier, but we should probably try to design buildings so if the Gulf Stream stops, we can handle the snow. We want to ensure that we make a society that can train itself, so if there is a surprise about what the future is going to be, it can adapt well.
Okay, thank you very much to all the speakers. We should be coming to an end because it's time to close, but no one should get frustrated if you still have a very, very last question or comment to do, or
I have one very
yes,
short. Sorry,
feel free.
It's for Anders. There is this colonization of the space, right? This race to colonize the space. My students are all like, oh, Elon Musk, and they see the future there, right? And then for me, as an ethicist, a philosopher, I think, how we do so that this race is a democratic race first. So how we include everyone. And secondly, why to put, also to invest? So convince me why somehow, or how do you see the problem to invest in this like colonization of the space and the possibility of living humans in the space, while we don't set the focus of the important questions here now, like what are we doing, how we preserve life?
Well, humanity has never actually solved all its problems before getting to the next one. It was not like we solved all the problems in Europe and then sent Columbus to the New World. It was rather, he went off, he found stuff, the rest is history. So I don't think the idea we need to solve things down here first and then we can do space, that would only work if we were totally coordinated, had this very rational approach to everything. That's not how it's going to happen. On the other hand, space is still hard and expensive. It's kind of useful to let Musk use his money for it, while we might want to use our money to solve our problems. Indeed, the best thing about space is that it makes people interested in solving important problems like closed biospheres, perfect recycling, alternative sources of food that are not dependent on agriculture. These are things that you could imagine that we should be doing anyway as part of development research and environmental research. But it's rather hard to get funding. But if you say it's for space, suddenly the sparkly fairy dust from the ionosphere falls on it and you get funding for it, which is maybe a bit stupid, but it's also kind of useful. I do think that the real issue is settling space is super hard. And it's not much there. The real value of space is actually that it's so big distances. Once you can live there, you're very safe because you're spread out. But it's not very convenient. Settling the Sahara Desert or Antarctica or the bottom of a deep ocean are much, much nicer and easier places for us humans, which is really saying something. But I think as a good long-term challenge, it's not a bad one. But it's probably a nicer place for AI and robots to live than biological humans.
Okay, thank you very much. So we now have to finish. We have heard many things about the long-term view from philosophy, from biology, from artificial intelligence, from many different perspectives. We can think of many things. Probably all of you have still many questions, as we probably all of us have. But remember that all the sessions today have been recorded and they will be edited and released on YouTube, so you can come back to the talks and to the discussions and look at them. And well, we hope that you liked the session and the seminar today. So thank you very much.